He's already online. I hope you enjoy the talk and maybe we have good discussions. The primary problem is the attendance. Everybody's, and then this being the third day, problem is more acute. Some of the people have left. Yeah. So anyway, but we have to do it. There are several people online. Partly half of otherwise was online, but now some people who were to be present physically, they didn't come. They are also enjoying online. Nice to see you here. I hope we enjoyed the talk. No.
Thank you, sir. Good morning, ladies and gentlemen. I would like to welcome you all for today's session. And I would like to introduce our chair for the session, who's SD Arora. SD Arora is serving as a professor in the Department of Mathematics at Amity University, Uttar Pradesh, Noida. An MPhil in Operations Research, MBA in Marketing, PhD in Information Theory. Dr. Arora is a gold medalist in MSc Operations Research. He has vast experience of more than 23 years in the education industry. He has published more than 12 books in the field of engineering mathematics, business statistics, and allied areas. Dr. Arora has made valuable contribution to research in information theory and guided more than 7 students for PhD, and he has several publications to his credit in the national and international journals of high repute. Now, I would like to welcome our speaker for today's session, who's Dr. S.C. Malik. Dr. S.C. Malik is presently working as a professor, HOD of Statistics and Dean Faculty of Physical Sciences, MD, University, Rohtak, Haryana. His field of research specializations are reliability theory, information theory, sampling, and applied statistics. He has teaching interest in the field of statistical methods and probability theory, optimization techniques, reliability theory, and stochastic process, real analysis, measure theory, and complex analysis. And he has published around 221 research papers and authored 3 books. He has supervised 48 PhD and 30 MPhil students in the subject of statistics. I would like to welcome you, sir, and you may start your presentation.
So first, very good morning to all of you, and really a great opportunity for me to interact through online mode to my learned Professor P.K. Kapoor. I'm very thankful to him, and really I salute him for his dedication and his motivational force for all of us. Thank you, sir. Good morning to all of you. So I am again thankful to our student, Professor Haridarshan Arora, who has been kindly agreed to chair this session. So I'm thankful to him once again. So congratulations in advance to this conference. So thank you, Professor P.K. Kapoor, for inviting me to deliver this talk. So before that, I'm sharing. Yes, I have been asked to discuss something about the reliability variations of a series parallel systems of MNI order by considering the failure laws relay. What we do in today's transformation age, everyone is interested to buy such a products that suit him in all respects. But suitability purely depends on quality and reliability of the product. Everyone is interested to buy such a product that suit him in all respects. How the question arises, how we can make the system a reliable one so that the performance of the system may be faultless to the users or the customers. Several research we have now on today, but the question arises how we can improve the system performance and thus how to improve the reliability of the system. Everyone is interested to know this question. Lot of research work has been carried out in this area, and several techniques have been suggested by the researchers to suggest the methods to improve the system performance and reliability in day-to-day activities. Yes, yeah. Oh, yes, okay. No. Oh, yes, okay. Now we shall come across these points. First, we shall discuss the introduction part, then abbreviation, system description, relative variation, illustration, regression analysis, and conclusion and application part with some references. Yes, the performance and reliability of systems working under different environmental conditions are required to be maintained either through the proper maintenance policies or by best structure of the components. Because the performance of the system purely depends on the structure of its components, design of its components. If you have a good structure of the components, then definitely the system will work or serve faultlessly. The reliability engineers have now become very serious in developing systems with high reliability in order to provide faultless services to the customers as much as possible. The researchers somehow got success in this direction, and they suggested some effective reliability improvement techniques, including the aspects of standby redundancy and arrangements of the components into structure. Today, we have some effective structures of the components in a system called series, parallel, parallel series, and mixed mode. In a series, you might be knowing that if a component fails, the entire system can fail. In a parallel, the system will work at the failure of the last component. In series parallel, we have mixed type of structures where we have we have the system in which subsystems are connected in series, and in each subsystem the components are connected in parallel, so we call it as a series parallel. Similarly, we can say parallel series and mixed mode structures. All these structures have already been discussed by the authors, and the authors have proved that the reliability of the system can be improved by using these structures. Over the years, several research papers we are having now today on reliability analysis of repairable and non-repairable systems using series parallel and parallel series structures of the components. Devo et al. In 2014 suggested and discussed a multi-state series parallel system under different environmental conditions. Hazara and Nanda in 2014 obtained some results on series and parallel systems of randomized components. Fezabati and Jerome in 2017 optimized reliability of series parallel system. Nanda et al. In 2015 analyzed reliability and mean time to system failure of series and parallel system. Chauhan and Malik in 2016 have evaluated the reliability of series parallel series systems by considering arbitrary values of the parameters. Yon et al. In 2018 discussed the series in parallel systems of the components. Khalil and Yusuf in 2021 discussed reliability models of a series parallel system with replacement at failure. Bermanjan et al. In 2021 compared the residual life of series parallel and parallel series system. On the other hand, sometimes it becomes very necessary to reduce and improve the size of the systems, because sometimes we need a small size of the system, sometimes we need a bulky size of the system. In that situation, we need to assess how the reliability will be affected by reducing the size or by increasing the size of the systems with the help of the components. So in terms of we can do this with the help of the components by introducing or by reducing the subsystems or individual components. In such situations, the system designers are bound to make necessary changes in the design of the system, and accordingly there may be variation in reliability of the original system, because we have an original system. The purpose of the present talk is to identify or to know the techniques which can be used to improve the reliability by reducing the subsystems in the original system and by increasing the number of subsystems in the original system. So first time, Nitika and Malik in 2021 obtained variation in reliability of a parallel series system of MNI order. MNI order means we have a parallel series system in which M number of subsystems are connected in parallel, and in each subsystem we have a finite number of components connected in series. So we called it as a parallel series system of MNI order. By addition, what they did, they obtained the variation in reliability by adding and removal of the components by considering exponential failure laws. Moore et al. In 2022 analyzed reliability variation of the same system, not the same system, but what the system they considered is the series parallel. But in case of Nitika and Malik, they considered the series parallel and series system. Now, Moore et al. 2022 considered analyzed the reliability variation of MNI order of series parallel system under exponential failure law. But the results available, or we can say that the existing literature indicates that not much work has been done on the variation in reliability of series parallel and parallel series systems with time varying failure rates. Most of the work has been done for the parallel series systems by considering constant failure rate of the components. Now here we in this talk is doing some different results by considering the same system, but the system is, here we are considering series parallel of MNI order by considering the Weibull failure laws. So to fill up this gap, the present study is here to consider the reliability variation in a series parallel system of MNI order with the addition and removal of the subsystems. We have an original system of MNI order in which some changes are going to be made with the addition and removal of X and Y subsystems respectively in series. We analyze the reliability of the modified system in relation to the original series parallel system and consider the impact of these changes on reliability. The components failure rates we are considering here relay failure distribution for the failure rates of the components, leading to derived expression for reliability variation. A particular case will also be discussed by considering a series parallel system of order 4 and 3. That is, 4 means we have 4 subsystems. In each subsystem, there will be 3 components working in series. So then we shall assess the reliability variation statistically by checking whether the reliability variation is authentic or not. For this, we will fit a linear regression model to check the goodness of it. And on the basis of the R square and adjusted R square, we can say that our model is best fitted for the reliability variation. The numerical and graphical representation of the results will also be highlighted to show the behavior of the reliability measures. The practical application will also be discussed, and we have a very important and interesting example for the practical point of view that in case we can see its application in a water supply system used in high-rising buildings. Everywhere this problem occurs. So we shall make use of the following notations to develop the system model and as well as to assess the reliability. RIST, we are considering the reliability of the initial system. PIJT, we are considering the reliability of the jth component in the ith subsystem. RIT is the reliability of the ith subsystem. And we denote delta RT means the reliability variation when X subsystems are added in series in the initial system. RAT, we are considering the reliability of the augmented system. Similarly, we have these notations for the theory. Now, here we have the original system. Here we consider a series parallel system. We have a series parallel system. This is the first subsystem, this is second subsystem, and this is the mth subsystem. In each subsystem, we have components connected in parallel. So that's why, but the subsystems are connected in series. So we call it is a series parallel system. In having of order m, because we have m number of subsystems connected in series and each has Ni number of components, or we can say that the first subsystem we have N1 number of components, in the second we have N2 number of components. Similarly, in the mth we have Nm number of components, and these are the finite number of components, we can say. And you might be knowing that the reliability of such type of system is the product of, because we have, first we need to determine the reliability of each subsystem. But each subsystem is a parallel subsystem. So for a parallel subsystem, the reliability is 1 minus the product of unreliability of the components. This is the well-known results already available in the literature. But for each we have the reliability, and then because each subsystem, all subsystems are connected in series, so again we can use the method of reliability for a series system. The entire system is a series parallel system, so it becomes the product of the reliability of all subsystems. So we can obtain this result. Similarly, let's suppose some changes are required. Let me make some changes like this. Let X series parallel subsystems are added. Suppose our interest is to add some more subsystems to the original system. Then if we add X series parallel subsystems in the initial system, then the changed subsystem Nj will be M plus 1, J for M plus 1, M plus 2, and M plus X. This is the added subsystem, added system by comprising X number of subsystems. So again, we can determine by using the same technique the reliability of this augmented, or you can say the added subsystem. We have this, the reliability is given by the product of the reliability of these parallel subsystems. So we can have the reliability this. Then now the modified system has, because in the initial we have M number of subsystems, now we have added X subsystem. So total number of subsystem becomes M plus X connected in series, and each subsystem has Ni from M plus X components are connected in parallel. So and this is the modified entire system. Then we need to determine its reliability. A very simple method. We can have reliability is RTST is the product from J from 1 to M plus X, the reliability of the parallel subsystems, all parallel subsystems. So we have, then our interest is to how much reliability is changed. So we determine here the reliability variation that is given by the reliability of the initial system minus reliability of the modified system. After simplification, we have this result. The change in reliability, or you can say variation reliability, is given by RIST into 1 minus RET. Or in simple words, we can say reliability of the initial system into unreliability of the added system. 1 minus reliability of the added system is unreliability of the added system. So we can have this result, RTS equal to RIS into RET. So what we conclude that reliability of the modified system will be equal to the product of the reliability of the initial system into the reliability of the added system. So no need to calculate the reliability of the modified system. If we have the reliability of the initial system and reliability of the added system, then make its product. That will give the reliability of the modified system. So similarly, in case sometimes we need to delete number of subsystems from the original system because of the bulky size or some economic constraints, sometimes we have to delete the number of subsystems from the original system. In that situation, suppose when Y series parallel subsystems are removed from the initial system, then this becomes the removed block diagram for the removed system. Because originally we have M number of subsystems. We have removed Y number of subsystems from it. So we have the removed subsystem is this was. Then obtain the reliability similar on the similar technique, reliability of the deleted subsystem, or you can say removed subsystem, is given by this. The product from M minus Y plus 1 to M, and the product and into the this reliability. So we can have. So when we remove M minus Y parallel subsystem connecting series having components Ni, I from 1 to M minus Y from the system, then this becomes the modified system. This is the modified system after deleting y number of subsystems from the original. So this becomes a modified system. So then again we can determine reliability. The reliability is given by RTST is equal to the product of these terms. This is or you can say unreliability of the product of the unreliability of the components. Unreliability product here, the product of the unreliability of the product of the unreliability of the components. So we can say it like this. So our interest is to determine the reliability variation. So reliability variation, we denote here delta R dash 1, R dash T is equal to the same technique, reliability of the modified system minus reliability of the initial system. So after simplification, we have this result. So delta R1T is reliability of the initial system into 1 minus reliability of the deleted system divided by reliability of the deleted system. After simplification, we can have this technique, that is RTS equal to RIST divided by RT. So reliability of the modified system in this case will be the ratio of the reliability of the initial system and reliability of the deleted system. But in the earlier case, when we added some subsystem, it was in the product. So reliability of the modified system is given by reliability of the initial system divided by reliability of the deleted system. So let's consider an illustration. Through an illustration, we are sometimes if we see a simple case. Here we are considering a series parallel system of 4 and 3 order. That is, we have 4 subsystems. This is the first subsystem, second subsystem, third and fourth. In each subsystem, we are considering here 3 equal number of components. 3 number of components. This and all these are connected in parallel. But the subsystems are connected series. So we are simply considering a series parallel system of 4 and 3 order. But here we are considering the failure rates follows Rayleigh distribution with shape parameter lambda and time to failure t. Then we can have the following results. So if t is the time to failure of the components which are following Rayleigh distribution with shape parameter lambda, then the reliability of the modified system, reliability of the complete system will be product of j from 1 to 4 into 1 minus, because it follows a Rayleigh distribution. In case of Rayleigh distribution, the reliability is e raised to power minus lambda t square by 2. So because these are 3 components, so power 3. So because we are considering here parallel, all these components are connected in parallel, so the entire reliability will be reliability of the first subsystem will be 1 minus this result. And because all these are connected in series, so it becomes the product of all these. So after simplification, we have the following expression for the reliability of the system. Suppose we are considering here some arbitrary values for the parameters. Our interest is to know what will be the effect or how much reliability will be varied by making some addition and deletion of the subsystems in the original systems. So with the help of these parametric values, we can have the following results. Suppose we are considering a t is the 4 units of the time for operation, and lambda is the original shape parameter for the original system, which is related to the failure rate of the components. So we are considering here 0.05 for the first, only to check how much variation in the reliability will be. Similarly, this is the modified lambda dash, the shape parameter for the modified system. Then if we add a single subsystem to the system, then reliability will be 0.030, and then with the increase of the operating time, with the addition of the subsystem, the reliability will increase. But if we increase two subsystems, then the reliability will further increase. If we increase 3, then the reliability will be further increased. So what we conclude that with the addition of the component, with the addition of the subsystem in the original system, the reliability will further improve. This is the variation in reliability. Actually, this is the variation in reliability. That is the difference of the original, difference of the modified and the original 1. So this is the variation. So reliability variation will increase with the addition of the subsystems. So graphically, we can show this reliability variation versus shape parameter and the time to failure, as we already discussed through the tabulated values. So what we check, our interest is to check whether the variation in reliability is authentic or not. So for this, we have established, or we have set or best fitted a regression line by considering the number of subsystems X, and by considering the shape parameters for the original system and for the modified system. So after fitting this, we have through regression analysis, we have the value of R square becomes 0.92 this, and at this R square, we can say that these values are very high. So we can say that our variation reliability is best fitted to the given parameters. So from this table, we have already developed the regression line on the basis of this. So similarly, in case of variation after deleting, in case of deleting subsystem, or see shape parameter. So we have the variation of reliability goes on increasing with the increase of the goes on increasing with the deleting of the subsystems also. It also becomes very high, but we cannot say that the So on the basis of the regression analysis, we can prove that yes, the regression to the variation reliability is the best. We conclude that here through this talk, we have developed a methodology which can be used
He's back. Mhm.
Am I audible now?
Yes, sir, you're audible, sir.
Yes, there were some technical problems.
No problem, sir. You may resume, sir.
So initially, initially a series system of M&I order is considered here, in which M number of subsystems are connected in series, and each subsystem has N number of components. The technique can also be used for other systems to check the reliability variation. So regression line is fitted to make the results to be authentic for so far reliability variation is concerned. Yes. Yes. The value of R square and this R square are calculated to check for the best fit of the regression model for the data. It has been noticed that after adding or removing subsystems in the original system, the reliability variation will go on increasing in both cases. So what we need, so to see the clear effect of the parameters on the system measures, the results are shown in the tables. So this is the beautiful application of the present work. What we need to do here, this work finds practical application in the water supply system. Nowadays, we are facing such type of problems in our houses. So water supply systems of high-rise building, particularly in case of high-rise buildings. By incorporating separate system for drinking and cold water, the weight of the water storage is distributed vertically in the building. effectively managing pressure for both drinking outlets and sanitary facilities. We need to consider a pressure reducing valve as the component, or sometimes we consider it as a subsystem. So pressure reducing valves play a crucial role in large pipe installation systems, particularly in tall structures. These valves are installed on each floor, regulating water pressure from main pipe and allowing adjustments based on specific requirements. The presence of gravity can result in varying water pressures on each floor, with the highest on the uppermost floor and lowest on the lower floors, originating from the overhead tank OHT. PRV's pressure reducing valves mitigate these pressure fluctuations, ensuring a consistent water supply. Installed in the main water supply line from the OHT and connected to the individual households for various uses like bathing and kitchen activities. These valves accommodate specific needs. Moreover, they facilitate the distribution of water from lower to upper floors using pumps. In this scenario, where additional floors are added or removed from the tower, adjustment in the design of these valves becomes necessary. That's why the present study can have or can be the application in this particular area or the field. So this is the valve pressure reducing valves, and each can be used in a high-rising building to utilize or to make the distribution of water equally among the flats for each floor. So these are the references used to develop this work and to consult for this. So we have these are references. Yes, thank you. If there is any question, please welcome.
Thank you, Malik sir, for sharing your insightful presentation. Even your expertise has added valuable contribution to this conference, and we appreciate your knowledge that you shared with us today. If there are any questions from the audience, the house is open for discussion. Please,
yeah. Yes, welcome.
Sir, great presentation and excellent work. Just wanted to ask you two questions.
Yeah.
You have used the relay distribution. So
Right.
whether it will work for any other distribution system?
Yes, definitely, definitely. We have already discussed several papers by considering, by determining reliability variation, by considering the constant failure rate exponential. Variable distribution we can also use.
So, but one doubt is there, sir. Normally, mechanical
Yeah.
component follow the Weibull distribution. So why you have used a relay distribution?
Here, sometimes we have increasing pressure or decreasing pressure. In that situation, the failure rate may increase or decrease. In that situation, relay distribution is the best lifetime distribution.
Oh, thank you. Thank you very much.
Yeah.
Any other questions from the audience or our chair?
any question from the audience?
Okay, so
I think,
moving on. As
Thank you,
as
sir.
there are no other questions, thank you so much, sir, for the presentation.
Thank you very much for giving me the chance to be here.
Thank you, sir.
My salute,
Now,
my salute to Professor P.K. Kapoor.
sir, Mike.
Yeah, it's nice to see you this morning.
Thank you, sir, for inviting me. And we are very happy to see you here in good health. Thank you very much, sir.
I missed your Rota conference.
Always welcome, sir. If you have, whenever you get chance, definitely always welcome to Rohtak.
We will meet soon. Don't worry.
Yeah, yes. Thank you very much, sir.
Thank you, Malik sir, for sharing your
Thank you,
presentation.
Professor
Thank you,
Arora.
sir.
Thank you very much.
Thank you, sir. Thank you, sir. So nice of you.
Now I would like to welcome Dr. P.K. Kapoor. I would like to request him to please felicitate our chair, Dr. S.D. Arora. Thank you so much, sir, for giving your valuable time. Guys, please, a round of applause.
Good morning, everyone. Moving on to the next session, I'd like to introduce our chair, Dr. Suraj Surendra Rane. Dr. Suraj Surendra Rane, Professor and Head of Department of Mechanical Engineering at Goa College of Engineering. He has over 25 years of teaching experience. He has completed his BE and ME from Goa College of Engineering, which is affiliated to Goa University. He has achieved his PhD in reliability engineering from Indian Institute of Technology, Bombay. He was the chairman of Indian Institution of Industrial Engineering. He is the institute coordinator for Ministry of Education, Government of India scheme Rashtriya Uchattar Shiksha Abhiyan. He is the recipient of Chairman's Special Award 2017 by IIIE for continuous innovative development of industrial engineering in its operations and significant encouragement to the industries in India. He was awarded Early Career Research Award 2018 in appreciation and recognition of his work in the area of reliability modeling by Association of Inventory Academians and Practitioners, New Delhi. He was the Chairman Board of Studies in BE and ME of Goa University. He is on the reviewer panel of various international journals. He is a certified Six Sigma Green Belt from Quality Council of India. Moving on, I'd like to introduce our speaker, Professor Rajesh Prasad Mishra, who is working as a professor in the Department of Mechanical Engineering at BITS Pilani. He completed his BE from MGCGV Chitrakoot and PhD from BITS Pilani. His research interests are in the fields of maintenance engineering, lean manufacturing, optimization techniques, manufacturing systems, and simulation and analysis of RAMs. Currently, he is guiding 4 PhD students in addition to considerable number of research practices, dissertations, and thesis supervision. He is also actively involved in research activities in collaboration with universities such as the University of Lisbon, LTU Sweden, UTK in Knoxville, etc. He has more than 70 publications in international journals and conferences. Professor Rajesh Prasad Mishra.
Okay. So which one?
Committee University card. No, this is not. Yes. Let's put the wax here. Yes. Yeah.
Thank you, madam, for introducing both of us. So let me officially, as the session chair, welcome Professor Rajesh Mishra to deliver his keynote. Okay, over to you, Professor Mishra.
Hello, am I audible? I hope so. Thank you very much, first of all, to Professor Kapoor for continuous blessing on us. Uh, that is why I'm here. And session chair, Professor Rane, as excellent man, has done a lot of research towards the area of mechanical engineering. Myself, Rajesh Mishra, trying hard to done something for the improvement of processes and methods for the industry. That is why I have chosen this topic, lean manufacturing. And this work basically done by my PhD student Nidhi Mudra, and I was guiding this. That has been taken a proper shape, and hopefully it will go for the publications. We will going to submit this paper to the journal. The topic as chosen is a part of a PhD, that development and validation of a critical success factor for integration of a lean, Six Sigma, and agile manufacturing. Basically, these three are the very key component of any industries to how to improve the method, how to reduce the waste, how to reduce the variations, and how it should be more efficient. So basically, lean manufacturing is towards focusing on reducing the waste, and Six Sigma is belongs to the reduction of variations, and agile manufacturing is directly attempting how a process should be efficient. So these three factors are really important, and the demand of these days. So this is the our means plan how I am going to present this, that what is the motivation behind and how we can what is the need of this integration, because already these systems are available. Then what is the objective of his study, and little bit talking about the research methodologies, and then talk about the discussions conclusions. So basically, when we are talking about the challenges of the industries today, so these are the challenges which we have observed through the various experts as well as the research paper. So the main challenge is the rapid globalization, as we see that wherever we are producing, it is directly connect to the any other part of the world, and we can sell the product. So this is the another challenge. Another, the market is too dynamic, because for a particular product, there are many manufacturer, many people are there who are trying hard. And in these circumstances, there is a deviation and the turbulence in the market. And as we have seen, the COVID is another put into the many constant, manufacturing things. Express, as we are keep growing in terms of the market and the customers also become the king of the market, and their expectations is very high. To looking at these challenges, which is the faced by the industries, basically the Indian industries, because we know that we are surrounded by the big giants like Malaysian industries and the Chinese industries, where the products are of low cost. So we are trying our level best to how to improve that. So looking at these criteria, as we try to develop such strategies where things can be much better in all for all its stakeholders, probably particularly for the manufacturer who are looking how to minimize, because the economics equations has been changed. Previously, we will govern by the economic equations like cost plus profit is equal to price. Now we are looking at that price has been fixed. You may be looking at the many products. This the price are not going increase in that way, which has to be with other factor. And another challenge that if we lose the profit margin, we will not have a motivation. Will not have a motivation to produce the product. So the only factor where we can balance this particular equation is the cost. So that is why the lean manufacturing basically attempting to reduce the wastage, and that will have a result in reducing the cost of the product. So other part, the variation is the another challenge because the product keep on changing, the technologies keep on changing towards the improvement side. So we will be looking the standardizations and other factors. So variations also we have to tackle simultaneously with respect to the variation in the parts. Means variety in the parts. So that is why we want to integrate. And third factor, which is talking about that the agile process, agility in the lead time, and so on and so forth. So agile manufacturing has another thing. What will happen till now that if we are not integrating these factors, if any industry wants to work only for the lean practices or work on the Six Sigma practices or agile, there will be the contradiction in as a whole, that how they can means if they are tackling a one factor, this is means they may leave to another factor. So that is why we started understanding this through literature and try to integrate, which will fulfill this all the challenges what we have mentioned in this slide. So these are the something which talking about the lean processes, and lean has been developed by the Toyota production system. Basically, Toyota company has given this philosophy, lean philosophy, and slowly the American universities like MIT has looked into and tried to develop the reduction in the waste. So that is how it is generated. Then Six Sigma concept has been given by the Motorola, well-known company in the electronics parts. They try and reach to the variation of Six Sigma level, means 3.4 parts per million, and so on and so forth. So that has become a standards for these industries that can be looked into these area. So that is what the thought process is, that one time we are tackling the reducing the cost, another side qualities also keep on enhancing in the other way. So, and the third pillar or third vertical, you can say, it is developing towards how faster we can reach to the market and customer. So this way actually tackling this problem. So that is what we mentioned here. So deploying a lean Six Sigma in isolation doesn't solve the problems which I have mentioned. So as giving a justification that Six Sigma will eliminate the defects of the process, and all those things has to be not been into the cost factor. So there is another thing that George Group in USA made an attempt of understanding the Lean Six Sigma, and they try to combine understanding the approach. Lean Six Sigma integrates with Six Sigma process with the variability and reduction the method, and which can be eliminate the waste. Waste means non-value added activity to enhance the performance. So these are the things has been taken. Then agility comes under the picture by LA University in 1999, and that has been given a much more impact and influence in the market, and basically capturing the customer in the particular area. So agile manufacturing, basically the strategy which industry can quickly react according to the demand and expectations. Because here the challenges are that industry has a lot of means kind of inventory, which is means associated cost and investment is huge. So balancing all these things, we need the lean as a and agile manufacturing, and taking into the Six Sigma, and making the company or following the practices or implementing these practices in a such way that we can tackle the all holistic view of a manufacturing company and taking to the next level. So basically, when we take these, so we have taken the various, gone through various research papers and try to understand the different impact over the academic side, as well as we have means consulted many industrial experts and their view, and trying to understand that how it can be combined effect can be given to the company. So this is what the systematic literature review for this particular process we have. We have selected the database, then different libraries. We have gone to the different combination of the keywords and selection of the titles, and we have restricted because the publication is too much in this particular area. So we restricted the time frame from 2000 to 2023, and in that way we found 2449 articles. Because if you ask me why you have not gone previously, because that such a huge articles cannot be managed in a particular study. So that is what the focus, and we have selected around 615 articles and come down to 350, and similarly we have understood and finding out the gap and come to this study. So this is what the descriptive analysis we have done for the literature review, that we have find out the journals, and we have distributed in terms of different demographies, understand the different concept available over the Lean, Sigma, Six Sigma, Agile, and try to understand. Basically, we do not want to be a particular company or particular sector. So we try to understand the different form of organizations, and these are the approaches which are mentioned here. Then we have also done the content analysis, where we could able to find out the critical factors, critical failure factors, what measurable performance and the frameworks in different sectors. So this is what the statistics shows, that how many papers belongs to the different categories, like Lean Six Sigma 57%, Agile manufacturing 23%, and Lean and Agile has combined 19%. And this particular graph is showing the type of companies and the type of the combination of a framework which are being published. And another side in the down, I have also shown that what are the different companies, different countries related to the publication. So we can see that India is impacting huge way in these process improvement, and this is what the need of our, if we want to go ahead for the competing with the Chinese companies, or the low cost manufacturing, or we can say reducing the price of the product. So looking at that, these are the key findings, that basically these frameworks, if we are talking about the company which can be implementable, only two researchers have developed this integrated model, which has combining the done work for Lean Six Sigma and manufacturing implementation. There are only few efforts has been made, 3 efforts to integrate this framework, which can correlate the critical success factor and critical failure factor. And the comprehensive set of tools, techniques, methodology, practice are not been mentioned clearly, that that can be a guide or cookbook for the industrial person to implement this particularly. So looking at this need and understanding the literatures, we could able to establish some of the objectives which can be studied. So we have identified the critical success factor. We have developed the critical success factor hierarchical model, which by using the fuzzy total interpretive structural modeling, and then validate by the structural equation modeling. So this is what methodologies we have developed to understand. Then these are the factors. Critical success factors has been identified combinedly for the Lean Six Sigma and Agile. And this is the diagram which is representing the associativity basically to the different factors. And this is but the factor wise, and this is the group wise. Both are same. This is the micmac analysis, which is showing which one is what factor is dependent, independent, autonomous, and is there any linkage. And then we have done those factors into the structural equation modeling. So this is the data where the Cronbach alpha showing 0.883, which is much higher than 0.7. So things are in right direction. And the validated factors in through a model. So this is showing the how we have gone. And we have for structural equation modeling, we have chosen the exploratory analysis and factor analysis. When we have done exploratory analysis, we combine 14 factors into the three major things so that holistic impact can be given. Because if you talk about more number of factors given to the industry, maybe not be effective. So that is why we gone here to understand. Then we have done the confirmatory factor analysis and try to understand how holistically it is valid. So the key findings here, like we could able to identify the 14 critical success factors, which has the 5 levels. And basically top management commitment and organization culture are means found to be a pillar of all these things. So by micmac analysis, we develop these things and find out the factors. And by SCM analysis, we could able to conclude that our study is useful for implementing the actually the factors which can taken care of Lean Six Sigma and agile manufacturing into the industry. So these are the some references. Thank you very much.
Thank you, Professor. Any questions from the audience?
You first applied the TSM, fuzzy TISM for
The understanding the constraints,
Yeah,
basically
yeah.
that what we have selected, whether they are going in a proper
no,
way.
on one hand, then you're talking of
Validation by the
no, sir, that parameter. Unless, did you also do EFA? EFA? EFA, yeah.
EFA is a
You didn't
part,
mention.
was the part of it.
Nowhere I heard the.
Yeah.
It
is there, sir.
Text. Huh? No, but he didn't speak. I thought.
Yeah. So through a software we could, and then this is I think SPSS 28 software is being used to run this.
Yeah, but the final results, the critical
Yes.
factors.
So basically in EFA what we done, that sir, we could able to finalize the 14 factors by the various data collecting process. And then we could, because 14 factors was much more, so we will try to club in the minimum number of factors, because yeah, if you will give you the large number of factors to a company, it will be difficult to handle and they don't know how to start with. So we could able to combine how they will this process. So that is what we have done the EFA.
Yeah, thank you.
Professor, any limitations are there for your integration?
Yes, sir. Since it is a holistic approach we have applied, so basically sometimes problem that if company is too small, they will not able to look up all the factors and they may confuse. Our industry is too big, then they will be understanding that where to start. Only thing we could able to understand that, okay, things has been made in the separate box. How these things we can combine and see the useful.
So, sir, I have one observation for you. I think EFA you are saying, but I find that you are saying 14 factors, right? And now 14 factor you have taken only sample of 100. I do not know how you are able to do that EFA. Because the sample of 100 is not valid enough to conduct even EFA, which you are mentioning. Another thing which you are mentioning that we have clubbed down this 14 factor. Actually, EFA does not do it. It is just a purification of scale is done, right? And then this factor which you are clubbing down, which you are saying the latent variables are there to describe, that has to be started from initial. That does not mean suddenly you have a number of items 14, 16, and then you are running EFA and it is getting converted into 3 critical factors. If ideally, if you see that you are saying 14 factor and also you are saying 14 factor, but you are saying that we are suggesting or recommending organization only 3 factors. So it is a contradictory. I think you can relook it how it is.
We can take your suggestions, but basically, the more practical example my students can answer because she was in the field and try to connect with them and how to come out. But
I do understand that challenge we feel.
because she might be facing that challenge. Thank you.
Yes,
Thank you.
Integration method and the application part of it, we'll definitely find more challenges, as we come across. That's
So
why
it is always there.
Yeah.
I mean, finding out the theory is hardly take effort, but implementing in a company has a huge challenge. Always.
If no more questions, I wish you and your student good success in research. And let me conclude this particular session. Thank you.
Thank you.
Thank you so much, sir, for the wonderful presentation. And I would like to request Dr. P.K. Kapoor to felicitate our chair, Dr. Suraj Surendra Rane. A round of applause from everybody. Thank you so much, sir. Uh, Moving on to the next session, I would like to introduce our chair for this session, Dr. Archana Singh. Dr. Archana Singh, having experience of more than 20 years in the academic and IT industry. Presently, she is working as a professor and head of Department of Artificial Intelligence, Amity University, Noida. Her research area interests include data sciences, deep learning algorithms, AI, image processing, AR, VR, business intelligence, data analytics, big data, and its application. She has more than 70 plus research papers, including the SCI indexed and Scopus indexed journals like ACM, Springer, Wiley, and others. She has been working on various research projects related to AI and machine learning. I would like to introduce our speaker for this session, Pao and Husing. Pao and Husing received his PhD in electrical engineering from the National Taiwan University. Since August 2007, he has been a full professor at the National Chung Cheng University, CCU. Currently, he is the director of the Research Center on AI and Sustainability, CCU, and the director of Taiwan India Joint Research Center on the Artificial Intelligence at IIT Roper and CCU. Previously, he was the Chief Information Officer, CS Department Chair, Dean of International Affairs, and the Director General of the Intelligence Technologies Department. He has published around 300 papers in the international journals and conferences, and he was the recipient of the 2010 CCU Outstanding Research Award, 2001 ACM, and Chapter Kuo Ting Lee Young, researcher. We would like to welcome you, sir. You may start your presentation.
Hello, can you hear me?
Yes, sir,
Am
you're
I
clearly
audible?
audible, sir.
Okay, thank you. Thank you so much for the kind introduction. And first of all, I would like to thank Dr. Kapoor for the kind invitation to give this talk. Due to the limited time that I have, let me just jump into the talk. This talk is on the work hour estimation for labor rights protection in distant water fisheries. Actually, this is a national project which we have been doing for the past more than 2 years in collaboration across different departments in our university. I'm from the Department of Computer Science, but this work is a collaboration across the Department of Labor Affairs, which is in the College of Social Science, and our department. The main reason we have this project is because there's a big problem as far as
Professor
the
Pawan Singh, we would like to welcome you for the session, but your screen is not shareable yet. Would you like to share it?
okay, I'm sorry. Let me share it. Okay, is it visible now?
Yeah, it's visible.
Okay,
You would-
yeah. Yeah, okay. So this is work across our two departments, and the major reason for doing this project is because there's a big problem in the labor rights protection of distant water fisheries. We were Taiwan. I'm from Taiwan, and I mean, the distant water fisheries was blacklisted by the European Union back in 2015. I mean, Taiwan was blacklisted because there were some labor rights problems. The fishermen on board of fishing vessels were exploited for long hours. I mean, they were forced to work for long hours. So because of that, there were many improvements as far as the distant water fisheries were concerned, especially on the fishing vessels. We got out of the blacklist, and then we entered the blacklist of the United States. So we are still currently in that list, and the reason is the same: is that the fishermen have been exploited a lot, and they also not only the work hours were very long, but the safety of the fishermen was also a problem. I think this is not a problem only of Taiwan. I mean, it is not only specific to Taiwan. Actually, many countries are facing the same problem because whenever the fishing vessels go out into the distant seas, there's no, I mean, there's no police control, or there's no exact control of how the fishermen are treated on the fishing vessels. So there's always a reason for suspecting if the laborers are protected when they are on the fishing vessels. So this, we started with this main motivation, and what we did, the professors from the Department of Computer Science, was we applied AI to exactly estimate how many working hours the fishermen have been working on the fishing vessels. So that was our main goal. We have Dr. Karthikeyan, who is also who is from India. He's from RV University, Bangalore. We have been working with him, and I would like to acknowledge several different professors from the different departments. And we had graduate students as well as intern students. We had intern students from India like Akash, Tugdul, Divneet, Amjit, Deepak, and Garima. Akash is from MIT, but not from MT Noida. He's from MIT Mumbai. Anyway, he did a lot of good work in this project. They have all gone back to India, but they were here for more than 3 months, and they did quite good work. Anyway, let me go on into the project. I'll introduce what exactly we've been doing in the project, and I mean, what was the final result, and what we are currently doing, and what are the experiment results. As you can see on the right hand side, there's a news of the death of an Indonesian fisherman on a Taiwan boat. And on the left hand side, you can see that actually Taiwan is one of the largest nations to export fish products. And we have a lot of longliners, that is the fishing vessels that go out into distant waters. Uh, as you can see at the bottom, we were listed in the illegal, unreported, and unregulated fishing by Taiwanese vessels. We were in the list by European Union in those 4 years. We came out of that list. We went into the list of the USA, and still we are now in that list. So the government of Taiwan has been, taking a lot of measures on how we can improve this situation. The main problem is that the fishing vessels are owned by Taiwanese, but the fishermen as well as the captain of fish are not from Taiwan. And the fishing vessel is also not registered in Taiwan. That is one of the main problems, for the main reason for why we are not able to exactly control what is happening on the fishing vessels. Anyway, the government has already started to apply restrictions and to pass regulations to ask the fishing vessels to implement CCTV cameras. So now on most of the Taiwan fishing vessels, we have CCTV cameras installed on board. If the fishing vessels are small, we have four to six CCTV cameras, and if it is a larger ship, we have around 12 cameras. And our job was to not only suggest where the cameras should be put on the fishing vessels so that we could get an estimate of the working hours. The other goal was to collect the videos and do applications of AI so that we could do good estimation. That was the main goal. But because the project is 3 years, so the first year, what we did was we helped them to use pads like iPads to do a manual registration of who is working at what time, etc. Initially, they used to do it on paper using the normal papers, but it was not it was not able it was not sustainable, and often there were a lot of problems. So now we made it all electronic. They could do a registration. That was the first year. In the second year, we analyzed all the CCTV videos. Now we have around 7 fishing vessels, and on each of those fishing vessels, we have around 8 CCTV cameras, camera videos that have been collecting camera videos for 6 months, at least 6 months. So we have a lot of videos here on the fishing vessels. And the second year, what we did was we tried to detect how many people are working for how many hours of time on the fishing vessel. So that was the second year. On the for the third year, which we are still doing, is to check the labor intensity of the people on board, and also to check the safety of the people. So that was the introduction to the fishing vessels. This is an example of the CCTV cameras on one particular distant water fishing vessel. As you can see, we have used red circles to mark out the areas where the fishermen are working. So there are 4 cameras which are focused on the areas that the fishermen are working, and the other cameras are along the corridors or in the restaurant where they have their meals, etc. So there are other cameras also. We've not been using the other cameras. We have been currently using only those 4 cameras which are targeted at the working area. On a fishing vessel, there are two working areas. One is the place. I'll show you the video later on, where they put the bait. That is the bait to catch the fish. And then the other 3 cameras are focused from different angles on the main deck of the fishing vessel, where they process the fish. That area is where the fishermen work for long hours, because they have to draw the fish out from the seas and process it, and then store it up in the cold storage, in the frozen storage. So because of that, they have to work for long hours. So that is the area where we have to check if they have violated any law. According to international law, for a period of 24 hours, fishermen should not be working for more than 14 hours. So at a stretch, they can work only for 14 hours, and then they have to rest for 10 hours. That is the international law. But if you have seen the videos, you'll be able to find out that sometimes they work for around 13 hours, 14 hours, and sometimes they go beyond 14 hours. And that is the violation of the international law. So that is what we need to check, and to make sure that the fishing vessels don't violate those laws. Okay, so as you can see, this is camera 1. This is from the top view. Actually, this is from the cabin of the ship's captain. And from the top view, you can see we have the daytime view on the left-hand side and the nighttime view. And actually, the fishermen are mostly working in the night, because only in the night we have the fish that can be caught from the sea. So most of the time they are working in the night. This is camera 2. Actually, it's on the level of the deck, and you can see there's always a overexposure of the lighting because during the night they need a big lighting, strong lighting to make sure that they can see what they're doing with the fish. And if you are using normal cameras, there's always an overexposure. Okay, this is camera 3. As you can see, this is opposite to camera 2, from also at the level of the deck, and you can see a lot of people working. Actually, as you can see from this image, you have more than 10, around 10 or 12 people working at the same time. And so sometimes we have to make sure how many people are working for how many hours, etc. Camera 4 is what I just said, is the place where they put the bait. So as you can see from the two images, there are ball-like structures. Those are the baits which they put it into the sea. So while the fishing vessel is moving, they put the bait into the sea so that they could fix the net that is being dropped into the sea. This is the area where they work for around 4 or 5 hours, or at most 6 hours. So they don't go beyond the limit that has been put by international law. So for this area, we don't need to exactly check how many hours they're working because it's much lesser than the limit. So they work only for 5 or 6 hours. So this is not our focus. But as you can see, there are lots of problems in these videos. That's the main challenge that we have when we are doing this project. So it's not as easy as you can see. One is during the night. I mean, because the fish on the fishing vessel, the fishermen always work in the night. So they have strong lights, strong lightings, etc. So there's an exposure of the light, and there's also occlusions, like you can see on the right hand side. The fishermen hang their clothes when they're drying, etc. Of course, they're not working now on the right hand side, but sometimes before they start working, they remove the clothes, but sometimes they forget, and the clothes are blocking the view of the camera. So this is something which we can always find. There are lots of anomalies in the videos. So another research that we have been doing is how we can do automatic anomaly detection in these videos, so that because these CCTV cameras, they are supposed to be proofs of the fishing vessel has not violated any law. But if the camera views are blocked, then there's no use of the videos. They cannot be used as proofs. So if we can do automatic anomaly detection and warn the people who are taking care of the cameras that the view is blocked, or there's some problem with the views, then we can do it. I mean, in time, so that we don't collect a lot of videos which are not usable. Anyway, so there are lots of challenges, as you can see from this chart. One is because of the lighting conditions. The other is all the people look very similar. As you've seen when they are working, they have rain caps, raincoats, rain boots, and even gloves. So because of the dress of all the fishermen, they look very much alike. So it's very difficult to distinguish who is who in the video. That is one of the problem. And actually, the association, the Tuna Fishing Association that is working with us, they wanted to know exactly who has been working for how many hours, from what time to what time. That was the previous precise goal that we needed to achieve. But it was very difficult because of the videos. I'll show you the videos later on. And then we wanted to check if there are any false detections, if there are any problems with the cameras, etc. Okay, so this was the whole architecture of what we did. Initially, for the first year, we as you can see from this pad, we developed a system so that they could make their attendance electronic. They could take attendance of all the people electronically. Before they used to do it using paper and pen, and we changed that. And then starting from the second year, we tried to estimate the working hours of the fishermen on board. We initially we used conventional models, as many of you might be knowing, like YOLO models. You only look once model, starting from version 5, 6, 7, even 8. We did it for 8. And we used very conventional and state-of-the-art object tracking methods, or object tracking AI models like Deep Sort, Center Track, Bite Track, we tried a lot of things with all the videos, and we tried to improve them by retraining the models. But before you retrain the models, we need to label the videos. So that was a big task. That was a tedious task. We had a lot of interns from different countries, and they helped us at least for the first month. They labeled all the videos, and then in the second month, they started creating the models, improving the models, so that we could do a better tracking as well as better detection of the human that are working on the fishing vessel. So let me show you what we did. This is the whole flowchart. I won't go into the details, but we did the data set. We tried to label the data set, that is the videos. We tried to do the training and the test data set, etc. Okay, so this is an overall view of what we did. So for each 24-hour CCTV video clips, we extracted one frame out of every 5 minutes. We could have done it in more detail, but because of the amount of videos we had and the large number of frames, so we had to do some sampling. So we extracted one frame out of every five minutes, and we counted the number of people in that frame, and then we aggregated all the 6 frames in a 30 minutes time slot. The reason we took 30 minutes as a time slot is because that is what they used to do. All their working attendance, whatever attendance they registered, was for 30 minutes time slots. So we had to do it for every 30 minutes. So we had to make sure that for these 30 minutes, are there people working or not? So if they're not working, this means these 30 minutes they are resting, or they are working. So this is what we try to do. And this also corresponds to what globally the other countries are doing. Globally, they're using another satellite-based GPS data. I'll show you later on. Anyway, so we try to do it for this fishing vessel. We did it for several fishing vessels, but in this presentation, I'm only showing one fishing vessel. So for this fishing vessel, this was the result of what we did with YOLO V7, the seventh version of YOLO after doing transfer learning. So we had to do transfer learning because the original models were not giving good detections. And as you can see from here, the blue curve shows you the number of people. We counted the number of people working, or that the number of people that came into the view of the camera. The reason we know that they are working is because the number of people has gone beyond the threshold. Of course, there's always a question of how to take the threshold. We tried to look at all the videos, and we did a manual analysis of what or what we can see from the videos, and we took the number five people as the threshold for them to start working. Because if there's less than 5, actually they're still preparing, they're not working. So beyond 5, it means the people have the group of people have started working. So that is the threshold we took. That's why we have a yellow line here. So beyond the yellow line, it means the whole group of people are working. So as you can see from the left-hand image, from the hour between 4 and 5, right until the hour between 18 and 19, that means they're working for around 14 hours. Something less or something more. Sometimes it is lesser than 14 hours, sometimes more than 14 hours. For January 30 of 2022, as you can see on the left-hand side, it appears to that they have already exceeded the 14 hours. But on the right-hand side is less than 40. No, I'm sorry. The left-hand side is less than 14 hours, but the right-hand side has already exceeded 14 hours. So you have an example of a non-violation of international law on the left and a violation of the international law on the right. So this is what for 2 days. The January 30 day, the date was January 30 on the left and January 31 on the right. Anyway, so this was what we did, and we compared it with Global Fishing Watch, which is a famous satellite-based data collection of where all the fishing vessels are on the globe. Throughout the globe, all fishing vessels are registered. So this data is accessible on the internet. We can get all the data related to the fishing vessels, the exact GPS coordinates, where they have been stationed, and for how much time. So this, based on the work that the Global Fishing Watch has published, and using their methods, we try to do a comparison between what they can estimate and what we can estimate. Of course, from an intuitive point of view, our should be more accurate than what the satellite-based data is doing, because that they are satellite data. They cannot do it much more accurate because they are satellite. There are lots of errors. Anyway, so we tried to do a comparison. We analyzed all the data that we collected, and we compared the vessel ID. So we had to make sure that whatever we are analyzing is the same fishing vessel in the satellite-based data. And then for the GFW, Global Fishing Watch data, they use slots of 15 minutes. So we had to take 2 slots so that we could compare, make a more, I mean, the comparison was matching. So they had their slot was 15 minutes. Anyway, so we tried to compare between our work and Global Fishing Watch for the vessel, which was called Jinpeng Sun. This is the Chinese name. For the voyage period from 1st of November 2021 to 1st of April 2022. These are the 4 cameras we used, as you can see. And this is the camera area layout. Camera 1 is in the upper cabin. Camera 2 is on the level of the deck, below the camera 1, and then camera 3 is on the opposite side. The tables, table A, B, C, those are the tables where they process the fish. So there are different tables. From this, we can see that different cameras have different views, so that they might be having different number of people that is being estimated from the videos. Anyway, we tried to make sure that we could get a good analysis across the different cameras, and we compared the precision as well as the recall and the mean average precision at 0.5 and also at 0.5 to 0.95. I'm sorry, I missed a point there, so it should be 0.95. Anyway, so as you can see, from the pre-trained model was not performing good. We tried to do a transfer learning, and after transfer learning, we got a good, a better precision as well as better recall. That was for 1 day. On the top, the table at the upper half of the slide. At the bottom half of the slide, that is for 3 months. So of course, because as we have more data, the recall and the precision has gone down, but it is still more than what we could get from the pre-trained model. Anyway, let me show you some video. This is camera 1. As you can see, this is during the daytime. So some of the people are, I mean, most of the people are detected, but some are not detected. As you can see on the right-hand side of the fish or of the fishing vessel, some people are under the deck. So under the upper part of the, I mean, they're under a roof type thing, but then those people are not detected. So this is camera 1 during the daytime, and this is the same as what we saw just now, camera 1, but is during the night time. So this is a retrained model. This was not the original YOLO model, because using the original YOLO model, we still had a lot of errors. Anyway, as you can see on the right, there's still some people which are not detected. This is from camera 2. Most of the people are detected. They are working. Some are processing the fish. Some are cleaning the deck, etc. I didn't show you any scenes with blood. So I used to tell my students, don't look at the videos when you have not started having your meal. Otherwise, you won't be able to have your meal. There are lots of blood, and because the fish are being killed and all. So it's not very, I mean, not
Excuse me,
very
sir.
attractive for the
Sorry to
eyes.
interrupt you.
I'm sorry?
Sir, I'd like to request to please conclude the session.
Okay. Yeah. So this is camera 3, camera 4. Okay, let me rush through it. This is the comparison between our method and Global Fishing Watch estimates. As you can see, the error for our method is less than half an hour. So it's 0.29 hours, which is around 17.4 minutes. And for Global Fishing Watch, it's more than 2 hours, 2.77 hours. So there's a large difference between what we could get and what the results we could get from Global Fishing Watch. Anyway, so we had overworking condition detection here. I won't go into details of this. We did chaos test, which is a statistic test to make sure what the manual record and what the automatic detection. I mean, there was to check if there's consistency between the data distributions from the manual as well as the automatic CCTV based detection. Anyway, I'll skip over all this, and we did the intensity labor correlation also. So we used the Pearson correlation, Kendall correlation, as well as distance correlation to make sure that the people across the different cameras, if they are working, I mean, the intensity of the labor is very high or low. So this was what we did. And then finally, we compared all the different working locations and to see which ones were having a higher intensity of labor. And then finally, we got a result that camera 3 is the location where we have a lot of, I mean, the labor is much more intensive from what the people are doing in camera 4. Yeah. This slide shows you all the anomalies that we found in the videos. I think most of them I've already mentioned. There are object occlusions, salt crystallization, sun reflections, etc. We compared all the 3 cameras for the same working location to make sure how we can analyze the exact number of people working in the working location. Anyway, let me conclude what I just presented. We had we had the CCTV videos from the fishing vessels, and we tried to analyze the working hours on the fishing vessels, and we compared it with the global fishing watch data, satellite-based data, and we got a much more precise estimate of the number of people working for the number of hours. I mean, so that was what I wanted to present. Thank you so much.
Thank you so much, Professor, for the very interesting presentation. And used like if it is used for social cause. So is there any question from the audience? I think the audience don't have any questions because it was very self-explanatory and you made it very, very much clear to. Am I audible? I think it's
Yeah, I can hear you.
okay. Like you have the number of.
I'm sorry, I cannot hear you.
Okay. One of the key indicator that you have shown in your presentation was the baits, like when you were taking the picture of the baits. So can you count the number of baits in the daytime, in the night time, and just to calculate if there is a good number of decrease of the baits at the night time, but definitely people are actually overworking at night, or whether you can consider that also one of the key indicator when you are calculating the overworking hours of your workers. I was just thinking on those lines.
Yeah, I think this is a very good suggestion. We will consider it in our future work. Thank you so much.
Okay, thank you so much. It's a great work. Thank you, and I congratulate you for doing this good work. AI, using AI for the social cause. Thank you.
Thank you, Dr. Archana. Thank you so much.
Thank you.
Thank you so much, sir, for the presentation. Now I would like to request Dr. P.K. Kapoor to please felicitate our chair, Dr. Archana Singh. Thank you, sir. start कर देता हूँ session. Good afternoon, ladies and gentlemen. I would like to start a new session, and I would like to welcome our chair for this session, Professor Rajesh Prasad Mishra. Professor Rajesh Prasad Mishra is working as a professor in the Department of Mechanical Engineering at BITS Pilani. He completed his BE from MGCGV, Chitrakoot MP, ME and PhD from BITS Pilani. His research interests are in the fields of maintenance engineering, lean manufacturing, optimization techniques, manufacturing systems, and stimulation and analysis of RAMS. Currently, he is guiding the 4 PhD students in addition to a considerable number of research practices, dissertations, and thesis supervision. He is also actively involved in research activities in collaboration with universities such as University of Lisbon, Portugal, LTU Sweden, UTK, etc. And he has more than 70 publications in the international journals and conferences. Now I would like to introduce our speaker of this session, Dr. Mili Pant. Dr. Mili Pant is Associate Professor at the Department of Applied Science and Engineering, IIT Roorkee, India. And she has published over 180 research papers and has edited several Springer Conference Proceeding volumes. She is the Associate Editor, Guest Editor, and Reviewer of various papers in Springer and InterScience Journal and IEEE Transactions. And she has served as General Chair, Program Chair, Session, and Track Chair at numerous national and international conferences, and has delivered guest lectures at various leading national and international institutions. I would like to welcome both the chair and the speaker in this session. And I would request the speaker, Dr. Mili Pant, to start the presentation. Ma'am, are you present? Dr. Mili Pant?
Hello. Yes, I'm present.
Yeah. Good afternoon, ma'am.
Very good afternoon to you and to others who are present offline and online. So just a small correction that the name of the department is Applied Maths and Scientific Computing. So I'm sorry, I didn't send you the updated CV, and the designation is professor. So apparently you are having old CV
okay,
of mine with me.
Okay, ma'am.
So it doesn't matter really because I'm here to present a talk. So just give me a second, I'll update it.
Okay, ma'am.
I'll start sharing my presentation.
Sure.
Hello, so welcome again, all of you, once again to this session. And sorry, this is another presentation that is being shared. So welcome once again, all of you, and we'll be talking about decision making through artificial intelligence. This will be the topic for today. And as we move along with our presentation, I would like to tell you a very brief, not a history, but some interesting facts about IIT Roorkee, because last year we celebrated 175 years of its existence. And IIT Roorkee is one of the oldest technical institutes in Asia Pacific, and it was the first engineering institution established in 1847 and became the first autonomous university of independent India in 1949. And in 2001, it was converted to IIT. It was from University of Roorkee to Indian Institute of Technology, IIT Roorkee. And presently, we are having 8,000 plus students and 500 plus faculty members with 6,000 plus staff and members, and 23 academic departments are there as of now. And we are opening new departments as well. This was the coin that was released during the 175th year of existence of IIT Roorkee. These are some other interesting facts about IIT Roorkee, which you can see here. It is among the top 400 universities as per the QS World Ranking, and it was ranked at 222 in 2022. And also, it is having several other interesting features, which you can see here. Now we'll come to our main topic, and that is decision making. So the thing is that decision making is involved in each and every aspect of our daily lives. Throughout the day, we are making decisions, whether consciously or unconsciously, but our brain is continuously working towards making a decision or making the things better and better. That is what is meant by decision making. But decision making, if you are doing it, I mean, subconsciously, you are always making some decision. Subconsciously, your brain is telling you to do something or another. But when we have to make some deliberate decision, or when we have to make a decision keeping in mind several factors and criteria, then things become difficult for us. For example, when we are making the decision for an organization, or we are making decision for a company, or so on, then we have to consider several factors and we have to reach to a conclusion after that. So a few things that are involved in decision making are knowledge, then what you are learning from that knowledge, and knowledge here basically represents the data that you are having, and how you are able to get some information out of that data will be the learning process. And once through that learning, you are able to make a decision, then it shows your intelligence, or how intelligently you have reached to a conclusion. So if we are telling a person what exactly decision making is, then very easily we can say, or in simple language, we can say that it is the act, in fact, it is an art of choosing one alternative out of a given set of alternatives. There are several alternatives present to us, and from those alternatives, we have to select something that is making an impact, or which shows our intelligence. So decision making is something related to how intelligently we are coming to a solution. Assuming that most of you are having management background, I'll talk about it in terms of management, that basically the types of decision that we talk about can be segregated as the strategic decision making, or the tactical decision making, or the operational decision making. So you all are very well aware of these terms, that what do these terms signify? Like strategic refers to the decisions which will have an effect on long-term basis. And usually these decisions are difficult to reverse. So once you are formulating a strategy, or once you are planning a strategy, you always go in a forward direction. I mean, you take one step forward for it. Then tactical decisions are the ones which are related to the implementation of the strategy that you have already made. And finally, the day-to-day operations that you have to perform in order to meet the tactical requirements, which in turn will meet the strategic requirements, are the operational decision making. Now, what does AI got to do with it? Why are we incorporating everything into artificial intelligence? Because decision making is an art of choosing the alternative intelligently. How intelligently we are able to reach to a conclusion. And when we take the assistance of machine or algorithms for fulfilling those decisions, or for reaching to those decisions, then we take help of artificial intelligence. And that is why artificial intelligence has got to do everything with it. Now, the topic, the title of this talk also involved complex decision making. So when do we say that our decision making has become complex? In the beginning, I said that subconsciously we are continuously making some decision or the other, or all our actions are based on some decisions that our brain is making. Our brain is so fine-tuned that we don't even realize when we are making an action or when we are performing an action. Now, the complex situation arises when we are doing these things in a conscious manner. When we have to consider several alternatives, when we have to consider several factors before we reach to a conclusion. So what happens is, usually we do not have one perfect answer. We cannot say that the answer that I am telling or the solution that I am giving will be the best answer or the best solution. But we try to select the best possible one. We can be having multiple answers for which we may require further experimentation before we reach to a final conclusion. Also, when you are having many options or many elements in your process, then again, you will have to do a very deep analysis of the data that you are having. In the very beginning, what we were talking about? We were talking about knowledge, we were talking about learning, and then we were talking about intelligence. So the data that you are having, particularly in case of organizations or companies, you require a lot of data with you, which is helping you in gaining the knowledge about that particular system. So the more data, the better it is, but the more data, the more complex our problem is likely to be. Then of course, when there are multiple options, you will have to select an option, although we do say that it may not be the best alternative, but it will be the best possible alternative. So even in that case, we have to consider several options that are in front of us. So if we put everything in a nutshell, then the complexities that we have in a system can be due to data uncertainty. It can be due to prediction uncertainty. Look, whenever we are talking about decision making for an organization or for a large system, then it will depend upon the data that we are having. How that data has been collected, whether we are considering dynamics in the data or not. There are so many things that are associated with the perfectness of a data. And we are never sure whether the data that we are having is absolutely right or not. So data uncertainty will always be there in our problem. Prediction uncertainty, how we are making the prediction, because we just saw that we may not get one perfect answer, but we may have to choose from the answers that we are having. So prediction uncertainty will be there. Then how we are making the judgment, that uncertainty is there. Finally, what action we are taking based on the judgment that we are having will give us the action answer. So there are so many, uncertainty is involved at every level that we are having. Now, what we can do through artificial intelligence. The moment we say data, the moment we say knowledge, the moment we say learning, AI automatically comes into the picture. Artificial intelligence is something through which we can analyze our data in a better manner. That is the work of artificial intelligence. That is what AI is supposed to do. It should be able to identify the patterns that are there in your data so that you are able to analyze it better, so that you are able to understand your system in a better manner, and so on and so forth. And finally, so that you are able to recommend a solution that is accepted by you all. Okay. So, first of all, know your data, know the type of data that you are having, understand what your data is made up of, and so on. In today's digital world, we have got data at each and every step. The data that you are seeing here is a bit old. Now it must have increased several times. Google, which has now become practically a backbone, particularly for the researchers who are working in, who are into research, they keep on Googling everything, and Google processes 24 petabytes of data every day. Facebook, most of us use. Daily we share millions of photos and so on. In YouTube, videos are shared. In Twitter, so many text messages are shared per day. Not just that, we have got so many satellites through which we collect the data. Again, it'll be in hundreds of petabytes. So there is no dearth of data. The only thing is the quality of the data that we are having and how we want to pursue it. So this is what is written here. In the previous slide, we saw what is generating the data. And on the right-hand side, if you see, you will see if we talk about it in a more technical term, then we can say that our data is available in the form of text. It is available in the form of numbers. It is available in the form of click streams, which again will be a number. It can be in the form of graphs, tables, images, transactions, videos, and so many other things. And it is very much possible that you are having a combination of all these things. Whether you are talking about a company, whether you are talking about an organization, whether you are talking about a larger system, or even if you are talking about a smaller system, depends on the type of problem that you want to consider. You will be getting a combination or at least one of these type of data. This is what was there in the previous slide. Now it is being shown in a more graphical manner. Basically, we can say it can be a numeric or a non-numeric data. But if we go deeper into it, if we want to explain it in a better manner, then this is how we can explain our data, the presence of the data. Once we have our data, then we need to identify the type of the data that we are having. So it is very important to know, because only then, since we are talking about artificial intelligence, we are talking about machine learning, we have to give specific instructions to the machines how to deal with the data. So here we should be knowing the type of the data that we are having, because for every distinct type, the machine will deal in a distinct manner. So how you are defining your data will depend on the type of problem that you are having, whether you want it in a numerical or a categorical format, whether you want your data to be in the numerical data to be in the continuous or the discrete format, depends on which type of problem you are working on. Then structured or unstructured. So structured data refers to when you are having a CSV type of format, that is mostly when you are dealing with the numeric value. And unstructured data means that you are having your data in some image format or maybe some video format, which you will be converting into numbers. Same is the thing with image or text. Like one thing what we have read from the very beginning, from our childhood, that machine can understand only numbers. Okay, so whatever we have to change it in the form of numbers only. But we should be knowing the type of data that we are considering so that we know how we are going to convert it. What type of conversion is required. Even text will be converted into some sort of numeric format. Images, no doubt, are a type of numbers only. But we should be knowing that this is an image so that we know the range of the, so that we know the scale that we are dealing with and so on. Once we are aware of the type of data that we are having in our problem, then we go to the analysis part, because that will be the second step. We know the data, that is, we are having some knowledge of the problem that we are having. Then we try to understand the type of data that we are having. what type of data we are having. Once we are aware of the type that we are having, we can go to the next step, and that is analyzing that. So for analysis, there are several things again that we can do. First of all, the description of the data that you are having, that is known as the descriptive analysis, which will give us an elementary idea what is happening there. The next will be the exploratory analysis, when you are further digging into the data and you are exploring the relationship between the data. So now statistics will come into the picture here. When we are talking about descriptive or the exploratory part, we are talking about the statistics at the back end, which is taking place. Then once these two steps are complete, then we come to the further part. We come to the next part, which is basically the diagnosis, the prediction, and the prescription. You have explored your data through the first two steps, description and then exploration, and then you come to the next part, in which you are trying to analyze what was happening with my data, what are the predictions that I can make with that, and finally, what are the prescriptions or the solutions that you are going to provide there. So types of statistics, I mean, this is something basic, so we'll have a quick look at it. But this is very important because any type of data analysis starts with the very basic step. The very basic steps itself will give us an idea what is happening to my data. Very basic statistics. We do not have to do very rigorous statistics in the first few steps, in the initial few steps. Whenever we are collecting the data, these are the two important type of statistics that we have to perform, the descriptive and the inferential one. So inferential one is, descriptive is the one in which we get the basic idea of the data, like the central tendency and the measure of a spread and so on. And the inferential part will be the one where we are formulating the hypothesis. Now we'll come to the learning part. Initially, we were talking about the data, what we can do with the data, what we should do with the data, rather. Because you will be having lots and lots of data. You just saw that whatever thing you are considering, whatever organization or the institution you are considering, the thing is that you are likely to have lots of data in it. Talk about healthcare industry, talk about tourism industry, talk about service or non-service industries and so on, service or manufacturing industries you can call. So you will be having millions and trillions of data. What you are going to do with that data, how you are going to get some important information, initial analysis, that we did in the last few slides. Now we'll talk about learning. And we have now jumped into the AI part properly. The machine learning part properly. Before that, we were talking about the statistics. Now, AI will come into the picture, and we say that there are three learning mechanisms, which are very basic learning mechanisms: the supervised learning mechanism, the unsupervised, and the reinforced learning mechanism. How we are making our machine learn something from the data that we have acquired. Okay. Now, these three learning types are, they depend on what type of work we are having. What is the objective that we are having? Whether we are having some target, whether we are not having any target with us, or we are talking about self-learning method. So reinforcement is something like self-learning method where we try to learn from the mistakes. Mistakes means whether we are getting the correct answer or we are not getting the correct answer. So whether we are penalizing our answer or whether we are not penalizing our answer, and so on and so forth. Supervised means that when the target is already known to us. I know what I have to do. Like in case of healthcare, when we have to check whether we are, whether we are targeting on some type of disease, whether the disease is there or not, whether some sort of virus is there or not. Then we have some samples in which the target is already known to us. Unsupervised happens when we do not know the target, when we are not aware of the target. So we try to make clusters. That is why it is said it is data driven. We should be having sufficient data with us so that we are able to create clusters. We are able to see the nearness of the patterns. We are able to form the patterns out of it. And then we are able to make some sort of diagnosis and prediction and judgment. Also, we can say these type of problems, the type of problems that we can solve with supervised, unsupervised, or reinforced learning. So when we are talking about the classification or the regression model, regression basically is the prediction of something. And there we make use of supervised learning algorithms. When we are talking about grouping of something, then we say it is unsupervised learning. Unsupervised learning we can apply there. And reinforced, although all three are decision making, but reinforced is a type of self-learning method in which we are trying to learn from our mistakes. And all these problems, they occur everywhere. Therefore, only the generic terms are being mentioned here. Prediction is something that we require in almost all the fields. Then classification, again, you think of a problem and you can apply classification in it. It is being used in, now we are using a lot in supply chain management in different phases of supply chain and so on. Transportation inventory, particularly transportation and inventory, there we use a lot of supervised and unsupervised learning. And of course, reinforced is also being used there. We do have types like semi-supervised learning and so on, but these are the most common terms, most common types of learnings that we have. This is an example of classification, that how the data is mixed together and our objective is to separate it. You can consider it as a part of grouping problem also, in which you are trying to group together the similar type of data points that you are having. You can consider it to be a type of customers who like one type of product and the type of customers who like another type of product. You are having two products with you, A and B, and so on. All these, you can imagine a problem and then you can model it in the form of a classification problem. Now the third part, that is intelligence. We talked about data, that is, we talked about knowledge, we talked about learning, that is understanding, and the type of problem that we are having, and finally the intelligence part. Okay, so the first two things were there. Now we are coming to the last part, and that is the intelligence part. So basically, how now we want to develop an algorithm which is at least at par with our brains, if not superior. Of course, our aim is to create something superior, but even if it works as per our brain, or even if it is able to make decisions as intelligently as humans do, then it is enough for us. So it depends on the input and it depends on the output that we are having. So this AI in itself is not something that is very new. And in 1955, it was developed. And we say John McCarthy to be the father of artificial intelligence, although there were more people involved in that particular project. But since the term was given by McCarthy, we say that John McCarthy is the father of artificial intelligence. Then some of the initial intelligent algorithms were made. Basically, the idea was same, that the machine is doing something that humans can do, or the machine is able to perform as well as the human beings. This is the similarity between the brain and how the algorithm functions. How our brains have got tiny neurons that helps in processing the information so that we can make a decision. Likewise, our algorithm is having certain parts which are processing the information through which we are making the decision. I'll try to be as fast as possible because I have exceeded 5 minutes. So the types of algorithms we have already seen, but this is just, the terms that you saw, supervised, unsupervised, and reinforced, they are as the learning methods, they are used as the types of problems that can be solved, and they are also used for the types of algorithms that we have. So on the left-hand side, you can see the type of algorithms that are there. And out of these, transformers are one of the latest concepts that we are having. And particularly, these are used in the language models, the text part that we have, and what GPT is made up of. And these are the network models that we have, which help us in making that decision. So on the very left side, you see the initial model of the neural network, that is a perceptron. And then we have a layered model. And once we keep on increasing the number of layers, then it becomes a deep network or a deep neural network model. And the term artificial intelligence, it basically refers to neural networks only. Then the RNN that you see here, that is recurrent neural networks. So these networks, they are basically used for identifying the text type of problems. A number of network models are there which help us in solving a variety of problems. And here is the list of, these slides, these contain the different types of neural network models that are available. These are some of the latest concepts that we have, that is deep convolution neural networks. Okay, so I'll stop now because we are running out of time. So any questions up till here, I'll be happy to answer.
Hello. No question till now. Please carry on. You have a time.
So how much time do I have?
I'm interested in knowing some example where you apply that classification, you know?
Okay. I'll come to the example. I'll share the slides again.
Hello, ma'am. This is Akash. Am
Yes,
I audible?
Akash. Yes, Akash, you are audible.
So I just wanted to know my paper in slot of 2 to 3:30. Let me tell you the names. Actually, I just wanted to confirm. That's why I joined early. Just a sec. Let me open that paper name. So this is
Akash.
yeah. This is 116 number. Adoption of DevOps to improve employee management.
Please stop.
I'm not sure if I'll be able to answer this question.
So its timing showing are 12 to 1:30.
I think
Akash Tomar, please put
librarian
up the
will be
mic.
able to help you in that.
Sorry?
Akash Tomar.
Yes, sir.
Akash will get back to after a few minutes. Right now talk is going. Okay.
Okay,
Please.
okay.
Sorry for interruption, ma'am.
No
You may please resume your presentation.
Sure. So some of the examples that we have already worked on are in the field of healthcare. And in the first slide that you see here, basically nowadays we are dealing with images. So this one was the classification of whether there are cancerous cells or not. So these were the different images of the brain in which are showing you the tumor location. So our objective was to see whether there is tumor, and the next objective was to see the type of tumor that is there. So this was on the brain tumor classification. And another example, why is my screen paused?
No, ma'am, your screen is visible.
No, it was paused. Abhi maine use theek kar diya hai. Another was, this one was interesting because here we were talking about the thermogram, not the normal imaging, but we are talking about the infrared imaging here, that where there are cancerous cells, the region will be darker. The image will be having a slightly dark representation there. So again, I mean, usually in case of breast cancer, mammography is one of the options, but mammography is a bit painful for the patient. So what happens is this thermography is a non-invasive technique in which the image is taken and then it is identified whether the person is having some sort of tumor growth or not. And if, I mean, further recommendation is needed, no doubt. I mean, but thermogram can be used as an initial check. So again, this will be a type of classification problem. These are the figures that are retrieved from the thermograms. Fine, mammography is an invasive technique and this thermography is a non-invasive technique. Then this work we did for the DRDO, and this again was based on infrared imaging in which the objective was to identify the target. So this camera that you see there was given to us by DRDO, and the images that you see at the bottom, these images were taken by the scholars in my lab, and then we tried to identify the different, I mean, here we are identifying the persons here, and so that it can be applied further in defense where we are able to identify the object, the enemy object. This you can see the different images were taken, images of car, person riding a bicycle, walking, and all those things. These were taken by us only in the lab. Still, there are several challenges on the application of AI because AI is totally dependent on the data. So if the data quality is, we have to do a lot of work on the data itself. Once the data has been brought into a proper format, then machine learning algorithms are applied. So poor quality data is one of the biggest challenges that we have, particularly in case of healthcare. We don't get good type of data. First of all, there are so many clearances that we need and so on. Then, I mean, it is very difficult to get real life data. Then in case of defense also, this data is again very restricted in nature, and the original data that we were having, images of tanks, etc., that cannot be shared. So it means that once we have used it, no one else can use it. It will be the property of DRDO. So whatever work we have done on the data, that cannot be shared further. So unavailability of training data. If someone else wants to test on the same data, then the person will have to collect his or her own data. Then these are the algorithmic problems like underfitting or overfitting, but this can be treated by modifying the algorithm that we are having. Lack of training and testing data, this is same as poor quality of data or the unavailability of data. Then imperfections when the data grows, that is to say when more and more data comes into your picture. I mean, you want to make your algorithm perfect by using more and more data, but that may not always give you a proper solution. Your algorithm may get stuck. So again, this is an algorithmic problem. But the main problem I'll still say is the data problem. Poor quality of data. Some other points that I wanted to include here were the ethical harms and concerns, because this is also gaining a lot of interest among the researchers now, because now that we have AI algorithms, we have a concept called artificial intelligence. But now we want a concept whether we are using the things ethically or not. So ethical harms and concerns are another things that are very much discussed by the researchers, and particularly some of the things that one talks about are the human rights and well-being, what type of emotional harm it is causing, particularly the Facebook and the social media things. So these things cause a lot of emotional damage to a person. So how we are using it intelligently. Then whether the system that we have developed is how much accountable it is, how much responsible it is, whether we are following the norms of security, privacy, accessibility, transparency, then whether the system that has been developed is safe and it is something that everyone can trust, whether it is causing some financial harm. Then what can be the social harm? What can be the social justice to be provided? How lawful, whether we can make it lawful or not, particularly in case of autonomous cars, etc., etc. Who will be responsible? Then control and ethical use or misuse of AI. The AI that has been developed, whether it is being used in a conscious, in a proper manner or not, whether it is causing some environmental harm, how to make it in and how to use it in an informed manner, whether there is some existential risk or not. There are several factors which are now being considered when one develops an AI model. So that's all for today. Now we can come back to the questions if there are any.
Hello. Any
Yeah.
questions from audience? Yeah.
Hello. First of
Hello.
all, I congratulate you, ma'am. It is a very interesting present talk, and I had learned a lot of things from this. I'm a management professor, so I just want to understand from you. You had mentioned types of problem. There you mentioned supervise, unsupervised, and reinforce. In supervise, you mentioned classification and the regression part, unsupervised clustering, and the reinforcement part, decision making. So, as you aware that in our management area, we have consumer behaviors and decisions are there. So, we can use reinforce methodology for understanding the problem and how decision making can be made through that methodology.
I think I missed the last part. Which type of algorithm will be best for your problem? Was that the question?
Yeah, this we would mention types of problem in artificial through artificial intelligence. You are saying reinforce you would use for decision making. So can you
Yeah.
elaborate on that part?
Have you heard of okay, no. So reinforced learning can be applied to the management problems, and people have used it a lot, particularly in case of prediction also. I mean, if you're proceeding in the right direction, you can give an award to it. And if there is an error, then you can penalize it. That is the basic concept. So it can be applied anywhere.
Okay, ma'am. Thank you.
Yeah.
Sorry, you want to ask? Want to ask? Okay, I think we are done. Thank you, Professor Pant. I think I met you after a very long time. I
Yeah.
know. Very nice presentation, and I know you are wonderful speaker and presenting all the things very beautiful. Thank you. Thank you.
Thank you so much. Thank you. Thank you, everyone. And have a nice day. Okay, bye-bye.
Now I would like to call Dr. P.K. Kapoor sir to felicitate Professor Rajesh Prasad Mishra sir. Welcome to the next session. So now I would like to introduce our chairs. Dr. Rana Majumdar. Dr. Rana Majumdar is presently working in the capacity of Associate Professor at Sister Nivedita University, Techno India Group, Kolkata. He authored many research publications at various national and international levels, indexed by SCI, ESCI, ESCIE, and Scopus, and he has published a book named Assessing LAN, and two of his book, Data Structure and Cybersecurity, is available online at HSRA Publications. He is also associated with an editor of Conference Proceedings. He has many 14 patents and one copyright to his credit. He is proactively involved with professional and associated with various bodies. He has been nominated by Marcus Who's Who and Forex to recognize his contribution to the field of education. His area of research includes digital image and video processing, computer vision, and software reliability engineering and machine learning. Now, I would like to introduce our next chair, Dr. Sachin Kumar. Dr. Sachin Kumar is Associate Professor of Computer Science at Cluster Innovation Center, University of Delhi. He is Executive Officer of the University of Delhi Foundation. He has been awarded PhD degree from the Department of Computer Science, University of Delhi. His thesis titled Modeling and Prediction of Building Energy Performance Using Machine Learning Approaches. His thesis primarily focused on developing and designing machine learning and deep learning models for energy performance optimization and prediction of energy uses to improve energy conservation in residential and commercial buildings to achieve the goal of sustainable cities and societies. Now, I would like to introduce our speaker, Professor Lalit Garg. Professor Lalit Garg is an associate professor in computer information system at the University of Malta and honorary lecturer at the University of Liverpool, UK. He has been a researcher at the Nanyang Technology University, Singapore, and Ulster University, UK. Professor Garg has supervised 200 plus master's dissertations, 2 DBA, and 5 PhD theses, and published 150 plus high impact publications in referred journals, conferences, books, 17 edit books, and 22 patents. He has delivered numerous keynote speeches, organized chair international conferences, and consulted countless public and private organizations for information systems implementations and management. Now I would like to call Professor Lalit Garg to start his presentation.
Hello everyone, very good morning, good afternoon, or good evening, wherever you are. Because in the virtual mode,
Sir, your voice is audible and you can share your screen now.
yes, I'm fine. Yes, are you able to see my slides?
Yes, sir.
Good. Presentation mode. Yes. So first of all, thank you very much indeed for this opportunity. I have physically visited the university in 2016, and since then I'm very much looking forward to have opportunity to visit again physically. But yes, I appreciate this opportunity. At least I can interact virtually. And so this is our tiny island nation, Malta. And my topic for today's talk is digital twins and satellite data analytics applications in healthcare. Well, Professor Pant has already discussed a lot about application of artificial intelligence in healthcare. So I will continue that. And for understanding artificial intelligence or machine learning, we have to understand complex systems. So to understand complex system, I would like to start with the Srimad Bhagavad Gita. You might be surprised, but they have already discussed these complex systems in two of its verses. Okay. So first is karmandevadkarasya ma phaleshu kadachan ma karmphaletu bhurma shango astvi karmani. Well, you all are aware about this. So you have every right to work, but not expecting the fruit out of it. Okay? And why is that? Because your deeds are not directly related with its outcome. Okay? Why? Because there are many, many other factors affecting the outcome. Okay? So, for making decision making, it's quite complex. Okay? We have to know all these factors. So, the all quest of human development so far, especially in AI, has been to understand all these factors affecting the outcome so that we can control this outcome. Okay? Now, this is also putting another question. Okay? So let the focus be not on the fruits and never be inactive. Okay? So that is putting a big question like, should we not consider fruits or not? Well, that is answered in the next chapter. So in the second chapter, they were saying, so there are two types of people. Okay, so in this, they are saying, loke asmin vividha nishtha pura prokta mayane ज्ञान योगेन Shankyanam, Karma Yogen, Yoginam. Okay? So there are two types of people. One is who work very, very hard and then try to get an outcome of that. And another type of people who collect knowledge, okay, and work on that knowledge. And the winner is, okay, knowledge, although this is the choice which path you want to go, but in the future chapters, they are saying, okay, so again, the quest of knowledge, okay, and also if we consider both, we should follow a holistic approach. Okay? So how can we prove that scientifically first, and then how we can apply this concept in improving our health? Okay? So for that, okay, we have to understand system. I'm sure you all are well aware about what a system is. Okay? So you know a system means when two or more entities are interacting with each other, and that interaction will decide the state of the system. Okay? So as in that verse it was written, okay, there are large number of entities and we are one of the entities of that system. That's why we have to either know about all these entities, else we should accept the outcome. Okay? So it's a very complex system. There are many, many entities interacting with each other. Okay? And that if you have less knowledge about these entities, then you make decision by rule of thumb or perception. Okay? So perception might be different than the reality, and perception comes from your experience. Okay? So which is not always true, because time is always time, place is always place, but what is actual only for that time. That okay? To understand it better, we can go for a first artificial intelligence algorithm. We call it hill climbing. So this is a hill, okay, hilly terrain, and you are at the beginning of this terrain. Okay? So from there, because of that angle, you can see only local maxima, but your perception will say you this is a global maximum. That's affect your decision. Okay? So if you want to be at the top of the world, you will just plan for local maxima, and you will keep only few items to survive. But when you reach local maxima, you will see global maxima, and it will be difficult for you to continue. So what to do in that case? There are two options. One is you should always be aware that there are many other entities affecting the outcome. So whatever you are seeing is your perception, or deciding is your perception. So there is always a possibility of error. So then you might perceive, okay, there might be something it's global maxima. So you are well aware about, or at least having doubt about that reality might be different. So you will take a different. Another possibility is to ask someone or share knowledge. So knowledge sharing, as we have already seen, will win. But how to share that knowledge effectively? That is the big question. Okay? We realize that if knowledge sharing is well effectively done, then the country might be developed, while if there is less knowledge sharing, it might be developing or undeveloped, depending on how much knowledge sharing is there. Or in other words, okay, because there is very little knowledge sharing, okay, you will always doubt what might be the outcome. So you will take very short-term decisions. Okay, so there is huge uncertainty. While if there is more knowledge sharing, you will take longer term. And if there is less and less uncertainty, you know about next 10 years, 20 years, or you can predict about that, then you will take long-term decisions. Or if there is a stability, for example, government stability, institutional stability, then you will take longer term decisions. And that will make country develop. Don't worry, if you don't trust me, I will tell you another algorithm, which is called greedy algorithm. Okay, you might have seen the Jastra algorithm for finding shortest path. Okay. So if this is again traveling salesman problem, so you are in a city, you have to visit 5 more cities. Okay. So if either your supervisor is informing about the next city only, or there is huge uncertainty, maybe how you will travel from one city to another, you do not have all this information in advance there. So what you will do is you will travel to the next nearest city, and then you will decide which city you have to go. Again, next nearest. Okay. So best first search you will use. Okay. And it might be something like that. Okay. While if you have all this information in advance and you see the holistic picture, like I have to visit all these 5 cities, and what might be the best route to visit all these cities. Okay. You might go to Google Map, you might do other analysis, and you will find out the optimum path before starting your journey. So you can clearly see, if you find an optimum path, you will save lot of time, a lot of effort, resources. Okay. So you will always be winner than those who are making short-term decisions. Okay. So you can easily understand, if you are saving lot of resources and time, okay, and making a better decision, then you will be more advanced, obviously, to develop. Okay. Now, again, going to that, okay, so if you work hard, okay, so you take decision through human intelligence only, okay, then there is a limitation. Okay. So manually you can collect limited knowledge, and your knowledge collected might be correct or incorrect, as we have seen in that example of hill climbing. Okay, so it might be sometimes incorrect. Okay. Now, then you have to process that knowledge. Again, you have only one brain, so you have a limited capacity of processing that, and that processing might be biased. We will see shortly what biasing we are talking about. And once you process that knowledge, you have to take decisions. And again, to confirm if your decisions are correct, you can take, or knowledge collected is correct, you can take only limited decisions. So you can analyze only limited knowledge, and you can get limited feedback. So learning is limited. Okay. So it's quite challenging to make decisions, okay, with limited knowledge. While if you use sensor networks to collect knowledge, okay, or we call it complete system is extended intelligence to an holistic approach. Okay, so you can have unlimited number of sensors, okay, collecting unlimited knowledge, okay, given the stored knowledge, written knowledge, all these you can collect. Okay. You can also ensure that the knowledge is correct by using various algorithms. Even we developed some algorithms to ensure the knowledge collected is correct. Okay. And then you have virtually unlimited capacity to process that knowledge. Okay. And then to further ensure that processing is unbiased and knowledge collected is correct, you can simulate action. Okay. And if this is incorrect outcome or unexpected outcome, then you can use reinforcement learning to improve that. Okay. So you can ensure knowledge collected is correct, unbiased processing, and then you can take the right decision. So there are various techniques available. I'm sure you all are aware about various of these techniques. So you can understand biasing. Okay. So there are many biasing. For example, optimism bias, large number of population is affected by optimum bias. So the simple example, during COVID-19, many people were perceiving that they are prone. So COVID can affect, kill anyone else, but not them. Okay. While some are just opposite of that pessimism bias, so they will highly pessimistic that the world gonna end. So they started going there or maybe saying last goodbye to their family. Okay. So they were highly pessimistic, and you can understand both decisions were incorrect. Okay. So there are large number of such biases, confirmation bias, anchoring bias. I'm not reading all these, okay, but you can understand affecting our decisions, okay, or taking us away from the reality. These all decisions are based on perception then. Okay. So how we can utilize this knowledge, okay, or understanding to deal with the global health challenges of like obesity, chronic diseases, okay, aging population, ever increasing health resources for the aging population, okay, and drug resistance, hospital acquired infection, medical errors, okay, global warming and pollution, which is responsible for many other problems, okay, like infectious or genetic diseases, viruses. We have seen already COVID-19. Okay. Then health inequality. You are healthy only if someone in China or Africa is healthy, otherwise he or she can infect you. You have already seen the example of COVID-19. So then two more, we have not given much attention to that, but stress and sleep apnea, almost half of the population is affected by these at least once in their life. And relationships and social health. So if your society is not doing well in terms of healthcare, you might not do well. And if your relationship, how it can affect your health, especially during COVID, you might have seen, but yes. Okay. So these are global challenges or emerging health areas. Okay. But to deal with that, we cannot just consider them as medical problems. We have to consider all these problems holistically. Okay, so these might affect society, so social problem, political, cultural. Okay, we might change our habits, community, communication, transportation, management, supply chain, okay, administration, education, finance, economical, behavioral, and geological problems, okay, or psychological problem. Okay, so what is the solution of these? As we have already discussed, okay, so considering this as a complex system and using extended health intelligence, which combines human intelligence as well as machine intelligence, okay, and using holistic. So these are the technologies we have already discussed, okay, AIML sensors, okay, like a smart wearables, cyborg, satellite, okay, wireless, then 5G, 6G, network for transferring data, cloud computing, telemedicine, robotics, gene editing, genomics. So you can understand, oh, so many technologies, you are getting confused with that. So how to use them together to ensure your health and not only your health, national well-being or the well-being of the world. Okay? And also you need economic growth to support all these developments. So this holistic approach for health is called digital. What a digital twin is? Well, before that, we will see how it can help you. So it can help predicting number of admissions at the hospital to ensure bed availability, to estimate waiting time. Okay, have ensuring health professionals are available whenever you need, and analyzing impact of various factors like climate change. Okay, minimizing the disease risk, assisting correct diagnosis. Okay, and take care of your health. Okay, even better capacity planning, better discharge planning, optimizing resource utilization and management, understand weather impact on disease spread, even pollution impact, okay, global warming impact, prepare health system for dealing with these impacts if they are negative, make public health policies, and alert public if there is any health emergency. Okay, so what up? It looks like a magical stick can solve all problems. Can it? Well, we have to understand what a digital twin is. Well, the concept is quite old. It came from manufacturing industry, okay, so representing something digitally before actually making physical changes, okay, or simulating, okay, digitally, okay, and seeing the impact of various factors so that you can finalize the design before actually physically creating that design, okay, so that you get the best design and minimum cost, because you are not required to design in physically again and again, and virtually you can minimize the cost. So it is combination of three things. Okay, so first is predictive analysis. Okay, so you collect data. Okay, so and then based on that you predict health status, disease risk, response based on the information already known. Okay, so how you predict or what data you need? You might need genetic makeup, genomic profile, present health status, which is called phenotype, environmental factors like weather, pollution, geography, where you are living, okay, diet, medicine, sleep, stress, lifestyle, activities, okay, exercise, therapy, relationships, social and economical status, your health history. Okay. So everything which can affect your health or can decide your health, you will collect that at one place. That's your digital twin. Okay. Then based on that, you have predicted, okay, you might develop these disease, these problems in future. No, I don't want these diseases. So you will prescribe to avoid these health incidents, okay, on negative impact. Okay. So you will control maybe environmental factors. If the you are a pollution is creating problem, you can go to a place where there is less pollution, or you might use air purifier or something. Weather is creating problem. Okay. You might move, okay, or depending on how it is creating problem. Okay. You might use air conditioner and all these. If diet is creating problem, you might change the diet. Okay, so that prescription might come if you need sleep, lifestyle changes, exercise, therapy, even to confirm that medical tests, investigations, so that if you are not able to deal them well ahead, then whenever this episode happens, you can deal with that. Okay? Treatment, surgery, gene editing, okay, using CRISPR, okay, or precautions and monitoring. So you have both of these, and then continuously simulate. If you use this prescription, what might happen? Okay, and selecting the best prescription. That's called digital twin. Okay, so it needs your general information like height, weight, shape, BMI, as we have discussed, your genomic profile, phenotype, your medical history, family history,
Sorry to interrupt
diet,
you, sir.
activity, travel history. Yes.
Sir, please wind up fast and come to the
Yes, I'm fine winding in 5 minutes. Okay, because I know many of you are hungry. This is already 1 p.m. in India, time for taking some food. Okay, so your predictive and prescriptive analysis. Okay, so this is not for individual we do, then we will get the best results. We do it for the community. So how the health of one might signal about the health of others. Okay, and we can continuously analyzing data. So we are generating new and new knowledge and making the most intelligent decisions. Okay, so it can help in many manner, as we have already seen, even predicting resource requirement, ensuring resource availability. All these we have already seen, reducing hospital visits. Okay, even it might open a new domain which is called medicine as an open loop system. So you can, instead of going to the hospital when you have a problem, hospital will come to you. Okay, so like doctor might call you, okay, you might develop this problem in the future, so let us deal with it now. Okay, and you can continuously interact with your own future or your own health. Okay, so it might also control drug resistance, hospital-acquired infections, okay, and insurance premium, and promptly recognizing factors responsible for non-communicable diseases, developing better public health measures, policies. Even you can analyze the impact of these measures or policies, health fraud detection and prevention. Okay, so because of limitation of time, otherwise I might have given you some real examples we are working on. Okay, so like for example here quickly, okay, we are collecting data from satellites about the weather and for environmental factors and seeing how it is affecting, continuously monitoring. If I have 4 minutes, then I can run this video, which is informing about that. But if I need to wind up, I can just close it.
Our Mother Earth, the only planet in the solar system, accommodates many species, including us. Complex life on Mother Earth requires stable conditions to flourish. But due to the access-human interface on Earth geology and ecology, many global problems are introduced like global warming, rising sea level, forest erosion, and many more. As a result, life on Earth experiencing instability. Health Organization discovered that 3 million deaths a year are caused by air pollution and is recognized as a contributing factor in the onset of heart disease and cancer. Along with the air pollutants, we must consider other environmental factors like temperature, humidity. Air temperature affects air movement, and thus the movement of air pollution. Because energy from the sun is absorbed by the Earth's surface, air near the ground is warmer than air that is further up in the troposphere. The warmer, lighter air at the surface rises, and the cooler, heavier air in the upper troposphere sinks. This is known as convection, and it moves pollutants from the ground to higher altitudes. In the case of humidity, it is a combination of dry air and water vapor. The degree of combination of this duo ultimately determines how hot or cold the temperature is. This scenario comes alive when we feel intense body heat and skin irritation or shivering uncontrollably. High humidity increases the rate of harmful or toxic chemicals in the air. It also causes dust mites in our homes, dampening air quality. Bacterial and viral organisms that cause respiratory infections thrive due to high and low humidity. Low humidity also causes airborne germs. This entire scenario leads to critical situations which are not only harmful to humans but also to other species. We need to find a solution that stabilizes the conditions and leads us towards a better world that everyone deserves. The Digital Twin of Earth project is among the promising technologies that will provide the solution to save our Mother Earth. Suppose we succeed in implementing fusion of digital twin of Earth and digital twin technology in healthcare. In that case, it will highlight the effect of the Earth's changing environment on particular human replicas. We can digitally create an Earth-like climate to examine its internal and external impact on the human body with the existing health conditions. GIS can be used to explore collating open
We are
data to
running out
develop
of
a
time,
digital
so
twin
please
of
come to
city
the
air
conclusion.
quality to inform
Just
public
50
understanding
seconds
of health issues, find ways to improve air quality, and move towards a healthy breathing city. We will be showcasing the impact of rapidly integrating multiple open data sources into an interactive digital twin using our cloud-based real-time simulation platform. In other words, healthcare scientists can tackle what-if scenarios without affecting the safety of individuals. The information that this project will generate, not to mention the insights that it will reveal, could drastically improve society's understanding of the challenges and risks of air pollution. More importantly, we will present multiple ways for reducing air pollution and allow cities to understand the importance of green energy, sustainable transport, e-waste management, e-mobility, and vegetation management. Moreover, every government needs to assess the air quality targets which are allocated to cities on annual basis.
Okay, so I'm not going to that further, but yes, just to add that this digital twin of Earth is a large project by European Space Agency, and ours is to focus on health because it has 5 objectives. So one of these is health. So satellite for health is looking after healthcare objective by analyzing the impact of environmental factors on human health. Okay, so thank you very much indeed for your attention and providing me some extra time. All the very best.
Thank you, Professor. for this wonderful talk about digital twin, which is an emerging technology and area and its application in public health. I would like to ask audience if there is any question.
Hello, Miss Dr. Lalit and Professor Kapoor here. Can you hear me?
Yes, we can hear you.
Just have a small question. You know, I work in the area of software engineering, software reliability. So whenever we develop a software and then we see how good it is, we give inputs and see the output. Like you said, the output is not correct or inadequate or something. You see the failure has taken place. And then we do keep on doing this and collect data on when the software failed. So can we can we apply machine learning methods? People say they applied, but they don't they don't forecast how many bugs still remaining in the software. That's the $1 million question. You test the software, you find failures, and then some still remain, and you release it in the market. The question is, in machine learning, I asked somebody, he said, we don't predict values like that. It is classified that this data we gave, this first failure took place, or no failure took place, and this kind of data. Have you any experience in that?
So thank you very much indeed for such an interesting question. In fact, it's really urgent and imperative. So you can see, okay, we worked on another project which is called um, handling missing data in medical questionnaire. So what we were doing there, okay, you can see if you have data, okay, and there is something missing, it can impute that data. Okay. So for example, finding out various relationships, like if I ask you 10 questions and someone else 10 questions, someone else 10 questions, and one is answering only 5 questions, and the remaining 5 I can answer by finding the relationship. Okay. So not only that, it can be utilized for missing data, it can also be utilized for ensuring the correctness of data collected. Okay. So if the imputation is quite different than the actual data you have, then there is something wrong. Either data is incorrect or your algorithm is incorrect. So in software, we can do that. Okay. Now, the another thing is about machine learning. The beauty is it can give you an answer based on the data, whatever data you gave, and whatever outcome you expect. Okay. So even if you give wrong data and you give the right outcome you are expecting, it can still find out the relationship with that and give you the right answer. Okay. Although that might be sometimes challenging. So we are using explainable AI, which can also explain you the relationship so that you can confirm that data is correct, the outcome is correct. Is that answering your question, Professor?
Thank you for the answer, sir. We'll get in touch with you. Thank you very much for this nice
Yeah,
presentation. Wonderful digital demonstration about public health and application of digital. Thank you very much.
My pleasure. All the very best, and feel free to contact me if you want to collaborate or you have any question.
Hello, Rana, Professor Rana.
Yes, sir. Yes,
How are
sir.
you?
Yes, sir. I'm audible to you.
How is everything?
Everything is fine, sir. I am here, sir. I'm seeing you through virtualization, so it gives me enough pleasure to be connected with you virtually. I can see you, sir. You are standing. I can see you back. In fact, sir, whatever question you asked to Lalit Garg, if you give me a permission, should I add 1 or 2 points on that?
Yeah, when are you coming to Delhi?
Sir, I'm planning to be there in the month of May, sir.
Be my host. I'll be the
The month
host.
of May.
Don't
Sir, definitely.
forget
Sir. I will
about
be
the
there,
money.
sir.
You fly and come.
It's-
fix your stay
Yes,
and,
sir.
you know,
It's my privilege, sir, to be always in touch with you, sir. I'm missing all those days very badly. Keep crying over here, silently.
see you then. See you here behind
Okay,
the
sir. Thank
keyboard.
you very much, sir. I will, sir. Definitely, sir. Thank you very much. Thank you.
Now I would like to invite Dr. P.K. Kapoor, sir, to facilitate our chair, Dr. Sachin Kumar. I welcome all you to the next session. The chair for our next session is Rear Admiral Alok Bhatnagar. Rear Admiral Alok Bhatnagar is a first generation naval officer and is an alumnus of 66th course of National Defence Academy, Khadakwasla. He was commissioned in the executive branch of the Indian Navy on 1st July 1985. Post commissioning, Admiral Bhatnagar was selected as the commissioning crew of minesweeper in the erstwhile USSR in 1987 and 88. At the sea, the flag officer has served on 14 different ships in various capacities, including appointments as navigating officer, executive officer, and commanding officer. Presently, the Admiral is the Deputy Director General International Affairs Division at the MIT. Now, I would like to call Harshita for the
Now, I would like to introduce our speaker, Professor Bimal Kumar Mishra. Professor Bimal Kumar Mishra holds an esteemed position of a full professor of mathematics and currently serves as a principal at Adarsh College. His academic accomplishments include obtaining a DSc in mathematics, the highest academic degree, as well as a master's in operational research and mathematics. Prior to his current role, he has held the position of a professor and head of mathematics at Birla University of Technology, Ranchi, and has been a faculty member at BITS Pilani. Thank you.
That's okay.
Good afternoon, everyone. So I will start by saying that an expert is someone who knows more and more about less and less. And I must say that this topic for this session will require a quintessential expert. Medical science has progressed to a level where it may be unrecognizable for a professional from a few decades ago. In this day and age of multidisciplinary approach to almost everything, medical science is also experiencing its share of ingress of other disciplines into its domain. As a child, I was mesmerized by the vastness of the universe and the unsolved mysteries of its very creation. But today, I'm equally mesmerized by the small but also endless universe that lies within our human body. With the developments of technology and its ingenious employment in the field of medicine, our knowledge as well as our ability to cure disease is improving at an unprecedented pace. At the cutting edge are devices like harmonic scalpel, IVUUS for 3D echocardiography, positron emission tomography, tapping tagging of individual molecules, gamma radiation cameras for high resolution images of tissues for early detection of cancer and the likes. On the administrative side, the use of robotics and digital algorithms for hospital administration is widespread. While the use of robotics in remote surgeries and medicine distribution in hospital wards has been in use for some time, deployment of digital algorithms in hospital management system, electronic medical records, and ICS algorithms for monitoring all 22 data points of patients in ICUs are some of the relatively new developments. But today, going well beyond these algorithms, there is greater use of artificial intelligence and machine learning in this field. Some of the areas which are being transformed by the use of these latest developments in mathematical modeling are recognition of unique patterns in complex medical data, decision making in critical care, prediction of disease progression using random forest models, predicting ICU mortality, complication and risk stratification, intelligence decision making, intervention in critical illness, etc., etc. I'm sure our learned keynote speaker, Professor Bimal Kumar Mishra, will delve on these issues and throw more light on the topic for the session, that is mathematical model on securing Internet of Things enabled hospital systems using artificial intelligence and machine learning techniques. Over to you, Professor Mishra.
A very good afternoon, the session chair. I would like to express my deep sense of gratitude to my esteemed teacher, Professor P.K. Kapoor, who has given me the opportunity to deliver this lecture in this conference, 24th International Conference. And I was a student in the year 1990 when I was a student of Masters in Operation Research. So really, I'm very much thankful to you. And in fact, the topic on which I will be delving my lecture today is on the transmission dynamics of ransomware on patient data in Internet of Things enabled hospitals using blockchain technology and artificial intelligence or machine learning. So, in fact, we are living in an era of Internet of Things. And in this 21st century, we are surrounded by whether it is hospital management or defense technology or business management, anywhere, Internet of Things is playing a critical role. And by the very same time, when we are very much involved in these all Internet of Things, the cyber attacks are now at a very, we can say in a very epidemic way it is going on. And this has created a lot of problem across the globe and inviting the technologists and the mathematicians coming together to find out a defense framework that how we will be able to defend this particular attacks which are going on. The recent of the attacks that was on deepfake, and the very, what we can say that in the coming 3 or 4 months, we have observed that we are moving towards a new cyber fraud, that is the voice cloning. So when we come across this deepfake, voice cloning, etc., and the general, in fact, the people who are not able to understand that what technology is, and they are in fact trapped in this cyber attack, then it needs the scientist's attention to find out a defense framework that how we'll be able to come to a solution for all these type of cyber attacks. And mathematics is going to play a critical role to understand the transmitting behavior of the attacks of the worms, that is the computer worms in the wireless network, rather in the wireless sensor networks. And to understand this transmitting behavior, the dynamical system rather, the differential equations are going to play a vital role. So, in fact, the Internet of Medical Things, what we are speaking about, so I will be concentrating on this only and try to develop a model and try to get into more about artificial intelligence and machine learning in IOMT. So whatever in the cosmopolitan cities or metropolitan cities, or rather we move towards the urban areas, today the medical sciences, in fact, and rather we can say that the medical management system are very much, they are dependent on the Internet of Things. The entire patient records, in fact, are being monitored properly by the system administrator of the hospitals. But what is going to happen when this particular medical record of the patients, they are leaked and come into the hand of the cyber criminals? And this, in fact, laid a very, very critical thing, what has happened. In fact, when we speak about this particular thing, when we speak about the healthcare industry, what is going on, there are different type of attacks. That is, one of them is the ransomware, which is recently happened in All India Institute of Medical Sciences, New Delhi. That was in the year 2022, November, when the entire hospital was at a stake for almost 10 days, when the patient record was being attacked by the cyber criminals. And there are different type of, there's a distributed denial of services, phishing attack, and there are these particular things, what the cyber criminals, they take the addresses, the personal health record, the laboratory test, the information of the entire patients. And they, in fact, they sell them to the cyber, to the insurance sector, the medical insurance sector, to, in fact, to flourish the business for the other third party. And due to this only, this cyber crime, this what happens in the healthcare industry is flourishing like anything. So I will be concentrating on the IoT-enabled hospital AIMS, the attack which would happen in 23rd of November 2022. And as I told you that for the 10 consecutive days, in fact, the entire hospital was at a stake. And the record of the patients, the appointments, and the other generation of the medical bills, the ambulance routing, etc., they were all, in fact, they when this particular attack was there, the data, in fact, was taken into the cyber criminals. They hacked the system, the main server, and they took all the data. And then what happened? As per the report of the various electronic medias, which was later on, it was not been confirmed by the government, but the media reported that this was a ransomware attack where the Chinese, in fact, they demanded rupees 200 crores to release those data. And you can just imagine that hospital like All India Institute of Medical Sciences, where in fact in the 21st century, they had to, for these 10 days, they have to go manually. So they went back. In fact, the entire system for 10 days was working like they were in the 70s or 80s. So it was a very serious threat. And what, in fact, this was not in India only which happened. This, in fact, happened in the United States of America, that this particular thing, it was in 140 hospitals in America that it happened, that there was an attack by one of the cyber criminals, and this made the particular system totally disrupted. And one of the greatest attack again happened in 2020, that in Russia, that they got all the critical information. So we can just see that whether it is America or where we are eating in Russia or in India, the cyber criminals, they are paralyzing the entire medical system and trying to get this good amount of money that is said to be ransomware. And also one of the very disturbing thing happened, that was in May 2021, that Ireland, there was a attack by one of the cyber criminal group said to be the Spider Wizard, and they demanded, you can imagine that it was around $19 million to get the particular data to be released by the cyber criminals. In fact, they took this a huge amount for releasing this data. So the entire world is in fact at a stake when we are moving ahead with these type of attacks. What is going on? So what happened in All India Institute of Medical Sciences on this particular date? So there was a mail from the director of the All India Institute of Medical Sciences by his official mail that he want to have a meeting with all the computer personals. And this was a message from the director, and the people there was an attachment there, and the system administrator opened that particular attachment. Once they clicked that attachment, so what happened? The main server was attacked by the criminals, and the information was taken out. So this particular, when there was a investigation going on, the police had taken two particular email IDs from where this particular mail had come. And that was mouse63209 at protonmail.com and doga2398 at the protonmail.com. So there were 100 servers, in fact, for this particular management system in AIMS, in which they had taken the 5 main servers, they had hacked it, and the information of around 3 to 4 crore patients, this medical record, including the very important persons and the most VIP persons information was being taken out by the servers. So this particular information which was being taken out, so this had led a particular, we can say, a debate among the technocrats across the globe that how we'll be able to secure the data, what in fact is being stored in the hospitals like AIMS, where the VIP persons and the general people record around 3 to 4 crore people information is being stored there. So what type of security measures we can take so that the data cannot be slicked away by these cyber criminals? So the blockchain technology played an important role. So how we can use the blockchain technology, which was very much started initially with the management e-commerce area, this blockchain technology. So how blockchain technology can be implemented in Internet of Medical Things to secure the patient information. So this blockchain technology, in fact, in any type of medical system, they take care of patient data security, drug traceability and supply chain security, and identity management and access control. I will be concentrating on patient data security. So when we speak about blockchain technology and AI, ML, etc., then there is the artificial intelligence. In fact, it plays a critical role for the detection of the anomaly system, and it monitors the blockchain activities. So whenever there is somebody is going to attack the main server where the patient data is being stored, then this artificial intelligence is able to detect this type of anomaly. And then another machine learning, this is in fact an intuition detection system where they're able to detect the real-time threat. So if we are going to merge these three, artificial intelligence, machine learning, and blockchain technology, so artificial intelligence is going to detect the anomalies. The machine learning algorithm is able to detect the intuition, what is going on. And just before my lecture, Professor Garg was speaking about the predictive analytics. So machine learning is also going to predict the potential security threat by analyzing the historical data, and it is identifying the threats that might indicate the future risk. And apart from all these, the other thing which in fact is there is the optical character recognition. So this OCR concept, when we are going to merge this with AI, ML, and blockchain technology, it is going to prevent our data more. So what in fact I come to a concept of personally identifiable information, that is the PII data masking. So PI data masking, everybody is knowing. In fact, when we get an Aadhaar card or PAN card online, so it is masked by data, but only the last four digits are appearing and other are being masked. So when we are in getting the information, when the patient information is being stored, the sensitive information. So the proposal here is to, apart from AI, ML, blockchain technology, we must try to use the PII data masking to, in fact, even if the data are being sneaked away by the cyber criminals, it should be masked. That is, the entire information must be star marked. There must not be any 4-digit, 2-digit data which is there available. By the help of the permutation, combination, and other things, the cyber criminals will be able to decipher it. Why to give these 4 digits or 2-digit data in the Aadhaar or PAN card? Why don't you make it entirely masked? So this, in fact, when we use this API data, the concept of public-private key comes into consideration. And then we'll be able to use where to use the PI data masking and how AI/ML can be used there. So I come to here a very specific blockchain block diagram here that this, if you are able to see, I'm coming this, making this the whole computer defense mechanism with the compartmental epidemic model, because these attacks are so much fast in nature that in a minimum span of time, maximum number of systems are being hacked by the cyber criminals. Therefore, they are termed as e-epidemic structure. So when we speak about the electronic epidemic, what is going on? So we take help of the epidemic diseases here into consideration. So what I considered here, I said that the entire system are susceptible in nature, whatsoever is connected in the hospital administration. So if there are 1,000 number of computers there, then all of them are susceptible towards the attack. Then we are going to update this particular system with the software and the hardware defense mechanism, maybe by the latest antivirus software or the firewalls or so whatsoever it is, making the entire susceptible population again into a very specific version control system, where the system is now equipped with all the defense mechanism, latest defense mechanism. But what we think that we are totally secured, but it is not the situation. The cyber criminals are now attacking our defense-proof systems with the help of the latest patches. So what happens there, even if there is the latest development in the field of software, the cyber criminals are going to make another type of mechanism to sneak into that particular system. And what is going to happen? That if there are 1,000 number of systems, they will be sending an email attachment. What happened in the All India Institute of Medical Sciences? That there was a message from the director AIMS that everybody has to attend a meeting. You open that particular link and the attachment and the entire description of the minutes of resolution of the meeting is being there, and you have to attend the meeting. And everybody opened it. And that what happened, the data was compromised. So out of 1,000, if we say 50 number of computers are, proportion of the computers are being attacked by the cyber criminals which open it, then the data here is being compromised. And this is the unauthorized access, what is going on. So when we speak about the unauthorized access there, so this in fact, there are two types of things what is going to happen. One is that the data may be tampered. And the other thing is that we are going to spread the particular thing, what is going on. So spreading it makes it more problematic. So when we are spreading this particular information, when we are going to, very sorry, there is a, yes. So the unauthorized, when the data is being compromised, out of 1,000, if say 50 number of computers are being compromised, they are now infectious in nature. When they are infectious in nature, then there is an unauthorized access of this information, and there may be two portions where is the data is being tampered or there is the spread of those particular information. Data tampering is not a very serious concern. They can change your name, they can change your sex, they can change your address or make another patient information placed there. So I place this into, suppose that if there is a tampering of the data, then 50 computers, out of 50 computers, 30 computers are being there where the data is being tampered. So I paste this into a quarantine class. I'm able to identify that which of the system, what type of the information is being transmitted. So if there is a tampering of the data, then I place those system in the quarantine class. That means the accessibility by the system administrator is not stopped. No further accessibility by the system administrator is there. I place them in the first quarantine class. But when there is a spreading of the data, which is very disastrous in nature, because this information is now being spread to the third party. The information is being stolen and it is being sold to the third party. So this is very critical, very dangerous situation. I place this in the second quarantine class. So it is highly sensitive. It is to be quarantined, where more sophisticated software has to be installed or more hardware components are to be given here to make the system go away. This particular information has to be stored. But one thing that has to be remembered, when the spread is there, when the particular information, when the data has gone, this cannot be taken back. But we can take preventive measures that further the data cannot be spread. Therefore, they are being taken into the second quarantine class. So once when the tampering of the data is there, the first quarantine class, and if we are able to introduce the latest software or more the firewall component or more the hardware components, we are able to recover many of the data which is being tampered by the help of the artificial intelligence technique, because the anomalies are being detected and then the data may be recovered.
I'm sorry to interrupt, but we are short of time. Can you please wind up in 5 minutes?
Okay, please.
Thank you so much.
So if it is a first quarantine class, then the data by the help of the artificial intelligence, we are able to detect the anomalies and then it may be recovered. But if it is not, we are not able to recover those, then this public has to be moved. This particular quarantine first has to move to the second quarantine class, where we'll use the machine learning algorithm to detect the intrusion, because maximum information is not spread. The information has gone, but our only target is that the information which is not yet spread, we must try to prevent those particular information. So machine learning algorithm helps us to detect those real-time intrusion, and then a proportion of them gets recovered. So once from the quarantine class first, artificial intelligence algorithm is used to detect the anomalies and the data is recovered. And for the second quarantine class, where machine learning is being used for detecting the intrusion for the recovered data, the recovered particular classes where the system is not recovered, we are now going to make a secure data block. And this secure data block is not robust in nature. I'm going to explain in the next slide. But once it is secure, that does not mean that again the crime cannot happen. The cyber criminals cannot sneak. No, it is not so. Wherever there is the accessibility portion is there, internet connectivity is there, you are again prone towards the attack. So what we say about the secure data block? So the patient information, where we are using the blockchain technology and what in fact we should do so that the data is 100% secure. So what we are doing, all the patient information, we are here now using the PII data masking with the use of optical character reading or by the natural language processing. We use the NLP and OCR technology to in fact mask all the information of the data here. And all of them are now star marked. So what happens in the hospital? They say that what is your date of birth, what is in fact your patient ID. Once you perform given the patient ID there, the person sitting, the receptionist, is able to give you the entire information by retrieving the database. And here, in fact, the crime happens. So what in fact we are saying that you mask the data, and then it can be retrieved only if there is a two-way authentication. The first is that you give a public key, that is the patient ID there, and secondly, by the help of the thumb impression or by the help of the retina scanning, when the private key is being given, then when public and private key both merges, with the help of the PII, your mass data, in fact, the information can be retrieved. So we're having a two-way authentication, three-way rather, that the patient report using NLP, they are masked with the help of PII, and with the help of this private public key, two-way authentication for the patient and the administrators would take place. Then only they will be able to retrieve the data. This PII data masking is now with the help of the blockchain. And then what type of model we are going to develop, I'm not going to go here. I am going only to say about the model, what I have developed, and the differential equations, what we are able to make it. So this particular, this was in fact the transmission dynamics of the ransomware, where we had the first susceptible cases, which was in fact being firewall and software was used to make it. A particular control version system is here. They're foolproofed. So with the help of, with a rate xi, the whole susceptible population gets into again a new susceptible class of a population which is highly proofed, and the malicious attack is there by the cyber criminals, and this cyber criminals, the system, in fact, the data is being here leaked or sneaked or being compromised at a rate of beta, making this susceptible class infectious in nature, and this susceptible class becomes infectious at a rate beta, and the population which gets infected is beta S2I. And there are two types of death here in the infectious class. A system may crash due to hardware or software problem at a rate D1, and this infectious class may get, they in fact may crash due to the attack made by the cyber criminals at a rate D2. And this infectious class, there is a tampering of the data. If so, we at a rate alpha, the infectious computer may go to a quarantine class, or at a rate gamma, if there is a transmission of the data, or if there is a, the data is being made public, they in fact, this system, in fact, at a rate gamma, they have to go to the second quarantine class. And again, they are infectious, therefore both type of death is there, D1 and D2. If this particular machine, if we are not able to recover the system at Q1 class, then this Q1 class of system go to a Q2 class. More sophisticated treatment has to be given here at Q2 class at a rate delta. So this Q1 class, when artificial intelligence technique is being used, then this at a rate eta, this quarantine class may recover. Or if machine learning algorithm is being used at a quarantine class Q2, then at a rate phi, they get recovered R. Once they are recovered, there is no death due to the attack by the cyber criminals. There's only a natural death. But the recovered class system may again become susceptible at a rate epsilon, and the system of differential equation is what we have obtained here. So you can see the beauty of mathematics, that we were speaking about the cyber criminal attack in the system of IAMT, and this is a system of ordinary linear or ordinary nonlinear differential equations. So mathematics here is what in fact we are able to here to find out the rate, that at what rate there is a disease, which is at what rate the particular attack is there, at what rate we are going to recover. So these rates are going to play a vital role. What we have also seen in the pandemic, that the mathematicians and using AI/ML technique, they are able to minimize the transmission of the disease. So in fact, I come to the conclusion here that if we are all aware about the reproduction number, so reproduction number here is also playing a very important role here. So what we see here that if we are here having a quarantine class 1 and quarantine class 2, then in the same, we are taking the data with the help of what from the unauthorized way, we can say that this is not a very relevant information what we have got from the data what in fact we have got, but we have tried to interpolate those data and get some information. So what we are saying to be able to say that when the software was not, yes, I'm going to conclude it, that when the reproduction, when a system which is infected by the cyber criminals, if one system infects 3 systems and the system are not updated with the software, then you can see the attack number, it is 1, 2, 3, 4, 5, 6. So 6 different phases of attack can be done there when the system is not updated. But when the system is updated and when the reproduction number is again the same, we see that the possibility of the new attack can be only on a single type. So the mathematics, in fact, is going to play a very significant role. So I'm going to conclude it that using a version control system like GIT and to maintain the record of the patients, we'll be able to more secure the data with the help of AI/ML technology, with the help of PII, that is personally identifiable information, making the data, masking of the data, we'll be able to control it. So we need to be secured more on this particular information. So thank you very much. This was all in this particular presentation. Thank you, Professor Kapoor, for giving me the opportunity to present my work here with you all. Thank you so much.
Thank you, Professor Mishra. I think it was a very insightful presentation. You've put mathematics alongside a field which is very interesting. I hope we get to see the deployment of this model in real life. And I'll leave the house open. If there are any questions, we can ask them now. I think there are no questions, but we have really enjoyed your presentation. Thank you very much.
Thank you so much.
Thank you, sir. Now I would like to call Professor P.K. Kapoor, sir, to facilitate our chairperson, Mr. Alok Bhatnagar. Thank you so much, everyone.